开始了。All right, so welcome to the ACM ICPC 2025 Taichung Regional Contest. ACM ICPC 2025. We're now live, and the contest has already started 20 seconds ago. We're now waiting for people to submit their first submissions. It should be very easy problems at the beginning in problem A. So we're expecting really quick submissions.
Okay, so let's see when we'll see the first submission. I guess it will be within the 5 minutes because there are some top teams that are pretty strong. If I remember correctly, there are teams having maybe there are Cold Forces, Legendary, Grandmasters, and even 2 in this round. So this must be a very exciting round.
Yeah. So for the regional contest, this time we have 14 problems in the problem set. Last year we also have 14 problems. The first place team solved 13 in total, and all 14 problems were solved last year. At the 60 minutes mark, we had 7 problems solved, and at the 90 minutes mark, we have 9 problems solved last year. So those are the easier problems, and according to the rule of determining the rankings, we rank the teams first by how many problems they solve, and if they are tied, then
okay, we can see the first. Yeah, the first submission comes out. Let's see, how is it? It's from NTNU Patrick Starr.
It looks like they should get a yes. It's looking like, yeah, it's looking
still
good
judging
now, but still judging.
It has passed 5 out of 8 test cases, and let's see if they can get they're the first solver of this problem.
Yeah. So now we await the result.
Yeah, as you can see on the live stream, you can see on the right, it is the judge queue. So if it's still loading, it implies that they don't get any non-accepted verdict yet. So yeah, if it's still loading, and you can see AC, and they get it correct.
Yeah, and for now we're seeing NYCU GBC Stolen getting the first AC, but actually they were not the team that submitted first. The team submitted the submission first was NTNU Patrick Starr. So should they get a yes on that submission, they will be the team winning the first to solve any problems award, not the NYCU GBC Stolen.
It's cool to see that our first submission is written in Python, because the majority of codes in competitive programming are written in C++, but the first submission is in Python.
Yeah, so currently we are seeing a lot of teams already have submitted their first submissions. There are a total of 25 submissions already, and they are now being judged in the judge queue. And another thing to mention is that our judge queue is not really the first come, first serve. It depends on the resources on the judge server side.
Yeah, so more specifically, it is a priority queue, and the judging order depends on the last time you make a submission. So if you make a submission like hours ago, then your code will be judged earlier. But on the other hand, if you submit quite frequently, your code will not be judged instantly.
Yeah, so previously we have seen teams submitting like crazily 20, 30 submissions consecutively in like 2-3 minutes last year. Because our judge queue is not first come, first serve, is a priority queue according to what Chris just said. They are likely to be judged later, way later. So you won't get the result in like maybe 1 or 2 minutes or immediately because you submitted too much attempts. So can we see their result? Oh yeah, I think NT and U Patrick Star did solve problem A, and as you can see on the scoreboard, they are now in the first place. And yeah, so they did win the first to solve of all problems award, and also the first to solve problem A award at 2 minutes mark. So now we have 9 teams solving the problem at 2 minutes.
Can we switch to the screencast? Like there is something like can you switch to the screencast?
Yeah.
Yeah. So NTHU to do. They made a wrong submission. I guess it might be a minor mistake, and they are submitting their second trial. Let's see if they can get it accepted.
So the screen you're seeing is
from the Tsinghua University, National Tsinghua University, NTHU to do, and they're submitting their second attempt.
Can we see their first submission's code, because
yeah, it would be worthwhile to take a look,
because that question is really easy. So usually for a real easy problem, if you got a wrong answer, it could be you misread the problem.
Let's
somewhere.
see their code.
So actually
I
we're
think we can switch back to this.
Yeah. Actually we're expecting around maybe 2 lines of codes to be sufficient to solve the problem A. That's our expectation.
Yeah, it was a minor mistake. The problem requires you to output final and then a white space number, but they missed the final, so they only output 94 instead of final 94 for the sample test case.
So we
see the second problem getting submitted.
Another one is problem E. That is also the problem that we expect to be the second easiest.
Yeah, I think we can put ticker here.
Yeah. So maybe we can show the problem A here. Can we show the problem A?
Sure.
Yeah, we showed problem A here, and we can have a little discussion and explain to our audiences.
Let me try.
Yeah. So, all right, we
proceed.
Yeah. All right, so now we have the problem A's problem statement. So in the problem description, we know that we are trying to read 3 numbers between 80 and 100 inclusively. So the problem asks you to read in these 3 numbers and check the maximum and minimum. If they differ by more than 10, our output is just like sample output 2, you output check again. But if it is within 10, Then just like sample input 1, 95 minus 88 is 7. So you output the second largest number, which is final 94. So it's a final and space and then the second largest number. So maybe there are a lot of possible solutions here. The most naive ones would be you try to read these three numbers and you can just minus the all these three numbers up and minus the maximum one and also minus the minimum one. And maybe we can have a second possible solutions here.
Yeah, I think this one is quite simplistic. So basically, you just maybe one way is to take the max, take a mean, or sort it, or whatever you choose, it should be correct. Yeah, and we can see some major changes in the scoreboard. Can we switch to the scoreboard?
Yeah, we're seeing also the problem M is getting solved now.
So we have three problems getting solved now. The first one, the currently leader is Fruit Advantages. They solved A and E with 2 problems and only 11 penalty. They solved A at 3-minute mark and E at 8-minute mark. Yeah. And there are also a couple of teams solving M. So yeah, I think those who solve AE will go to solve M, and those who solve AM will go to solve E in the next stage.
Yeah, because in the contest area, all our contestants can see the live scoreboard. So currently, they can see there are teams that have solved A, E, and M. So these 3 problems should be the easiest. And as we mentioned before, the rule of ranking will take all your correct submissions to all the problems and see. First, we see how many you solved, and then second is your penalty. The penalty is, for example, if you solve a problem at 5 minutes mark, so that penalty for that problem will be 5. And should you had a rejected submission, for example, you output the wrong answer, or your program runs like maybe it takes too much of time, it will result in the time limit exceeded error, then you will receive 20 minutes penalty. So it is always better to check your code, and when you have confidence that it will be correct, you submit it. Because just like we had a team in the beginning that they tried to submit a solution in rush, and they received the wrong answer that would add 20 minutes to their penalty.
Yeah, and we can see that very excitingly, Notebook, the current leader, have solved F, which is not expected to be the 3 easiest problems in this problem set. And we can check their screencast. Can we see their screencast? It's quite exciting that they are actually not working on E. Instead, they are writing B. When I was testing the problem, B was not quite easy, but I think they figured out the trick at a very early stage.
I think problem B was our 4th or 5th.
No, it was actually expected to be the sixth easiest problem.
Yeah, that's interesting, because that shows how good they are. Because normally we have 3 people in a team, but they only have 1 computer or a screen to try to write the code, solve the problems. So it's very important to you need to distribute people to different problems and try to distribute your resource. So normally there is 1 person who read maybe first 4 or 5 problems. So in our problem set is 14, maybe A, B, C, D would be read by the same person. So today the problem A was very easy. That person could just solve the problem A and immediately go to the problem B and try to think of a solution while his teammate or her teammate is trying to solve other problems.
Now we can see A, B, E, F, and M. Those 5 problems are getting solved.
What was the only problem that we think should be the top 5 easiest problem that is not getting solved right now? Because we said
all of them are getting solved, I guess. So,
but because we said B was the 6th easiest problem. We should have one.
Let me take a look.
Yeah. Do we have the?
Yeah.
Yeah.
Let me record it.
I think it was problem. Yeah, we're trying to find our problem list. Where, yeah.
Now let me take a look.
Yeah, as Chris taking a look, which team is this?
A, E, M, F, K, yeah.
So, yeah, okay.
Haven't been solved yet.
It's problem K, and
yeah.
maybe we can take a look.
But I think B is not necessarily hard. When they argued that B should be placed at 6, I actually had a short debate with one of the judges, because I think if you get the idea of B, it's actually easy to be written. But K is implementation heavy instead, though it's easy.
Yeah. So.
Okay, I think we can switch back to the scoreboard.
Yeah. So currently we can see our top 30 all had 2 problems solved, while the leader now had 4, and they are the team STD ABS with 4 problems solved and 39 minutes of penalties, and also the team Strong Zero with 4 problems solved and 43 minutes of penalty. The team Strong Zero from National University of Singapore, I think they had a international grandmaster.
No, legendary grandmaster.
Legendary.
Yeah, both SCD ABS and Strong Zero have legendary grandmasters in their team. I think their personal best ranking. They have. I think they have one contestant, pretty strong in each of them, and yeah, they get 3K plus rating on Coforces.
Yeah. So for the Coforces rating, if you are a newbie into the Coforces, currently you will get a rating of 0. That's your starting rating. And after you participate in contests on Coforces, you will start to earn or lose the rating. And the rating is calculated by Edo rating methods. So if you do it very, very good, you will earn the ratings very quickly. But if you do bad in the contest, you lose a lot. So currently, the first place, like the strongest man in the Coforces, I think they had a rating of 3,500, 600.
I think 3.7K.
Yeah. And actually, it's very, very rare to see people having a 3K plus rating. So that's why they are called legendary grandmaster.
Yeah, and meanwhile on Coforces, because Chuck mentioned Coforces, I think today there is also a mirror contest on Coforces. So if you're interested, you can register there and yeah, play around the problems.
Yeah, we just checked. Currently, the first place in Coforces is the rating is 3,747, 3747, and we only have 59 people having a rating that is at least 3,000.
Yeah, I think we can also talk about the code versus mirror contest that's ongoing.
Yeah.
The first, the current leader solved 2 problems within 3 minutes. They solved the first problem just in 54 seconds. Yeah, impressive.
Yeah. So that was also our expectations to all the contestants, because the problem there was really easy. You actually needed only 2 lines of code. First time to read the 3 inputs, and then you can directly output the result in the second line. So that is why we are actually having people solving the problem within 1 minute or 2 minutes in our mirror contest. So now we can see our scoreboard, because the easiest problems are now getting solved. We have 4 teams now solve 4 problems, but it seems like we have another 13 teams solving 3 problems. Yeah. Okay, so now most of our favorites are in top 20 currently. So the team STD is leading the competition by 4 problems now, followed by Strong Zero, and they lead Reventilate and NYCU Cardensen Tree 2. Yeah. So maybe we can now play the surgeon video of problem E, or problem M. I think we can start with problem E. It's the second problem that gets solved.
Okay.
Yeah, so now we play the surgeon video of problem E. 现在有结束，那吃了。And we just seen the 10 fruit advantages from National Taiwan University. They have solved 5 problems and is now leading the competition. But no surprise, they solved the easiest problems that people can see there are other teams solving it. But now one of the easiest problem that we're expecting to see quick submissions that is problem K, and still we see no submissions on that problem. So
I don't think people are going to submit problem K this early.
yeah,
Though the judges think it is an easy problem, I personally believe the statement can scare the contestants off. Maybe you can take a look on problem
Yeah.
statements.
So problem K,
Yeah, I can.
yeah,
Have you seen problem K before?
yeah, I've seen it.
Yeah. So, basically, it is a number search. Yeah, you can see like just as some interesting game you will see on the newspaper. You need to find some expressions such that it matches the numbers to find. So, for example, you can see the blue expressions 67 are matches the first one, and for the red one, it's indicating 727. 7, yeah, and
So-
yeah, we can see the test cases. So it's same as that one. Yeah, it is. You're given a matrix of numbers and operators, and you need to see how many expressions match such that the calculated result matches the queries. So in this test case, you can see it is a 9 times 8 matrix, and there are 4 queries to answer. The queries are 67, 420, 3, and 727. It actually is what the figure is indicating. So yeah. But the contestant need to be careful that when an expression reading from left to right and right to left should be counted as the same one. So, for example, the 727 on the third row should be counted twice.
Yeah, so this problem actually looks like if you are starting in computer science, then for most people in their freshman year, there is a course called Introduction to Programming, or the similar ones. Yeah, this one is actually the prefix or postfix problem in, I think, in the like.
If you solve it like that, I guess the problem setter got you, because if
Yeah.
you solve it like that, you'll get a time limit exceeded.
Yeah, it should be. So, but there is a little trick here that you can speed it up. Maybe we can try to
Talk about it a bit.
talk about.
Yeah, so as you can see, there are only plus and multiplication operator in this problem. So you can maintain the last term of the multiplicative term and the last number. So when you add a number to the end of the expression, it's actually effectively times 10 plus that number. So in that case, you can maintain the expression within O1 time.
Yeah, great.
That's the trick.
So this problem actually, I think it only requires this speed up, and then you would get get your program accepted. So it's quite easy, but also not that easy. You still have to do some speed ups and some little tricks.
Yeah, of course.
Yeah.
And I believe top teams at this stage may not want to deal with this implementation heavy problem because,
Yeah, again, it is to the rules that how the penalty is calculated.
Yeah,
So,
some problems are idea heavy, but implementation easy. Implementation light, so they might work on them first.
Yeah, because the penalties, as you can see, we had fruit advantage first to solve 5 problems, but now they are not leading the contest. The leader had only 78 minutes of penalty. The reason is because that penalty is summed up for all the problems penalty. So let's say if you have a 5-minute penalty on problem A and you have a 15-minute penalty on problem C, let's say this, then your penalty would be 5 for A and 15 for C that summed up. So your penalty would be 20 minutes. And that 5 minutes and 15 minutes, they are started to count since the beginning of the contest. Yeah. So currently we still see only 5 problems being solved: A, B, E, F, and M, where B was actually the judges thought that problem B should be harder than problem K, but just like Chris said, it could be implementations light.
Yeah. When we have 3 teams testing this problem set, and all of us, including my team, we solved B, I think, after 2-hour mark. But these teams are so strong. Yeah, they find the trick, find the key idea, and solve it within a very minimum time.
Yeah. So now we are 30 minutes into the contest.
Yeah.
Yeah, PC Komaki is now leading by 5 problems with 78 minutes.
Here we get 4 teams solving 5 problems. Maybe we can peek on their screen and see what they are working on.
Yeah.
Yeah.
Well, let's
start with PC Komachi. Yeah.
Yeah, the team that is leading now, and they just solved problem B, I think 3 minutes ago. So let's see what problem they're working on now, because this team should have 3 very, very strong members, and they should be doing this 6 problem now. Yeah, let's
take a look at PC Komachi's screen. Okay, let's see what they are working on. Oh, they are writing I's problem about geometry. The problem statement, if we conceptualize it, maybe we can display it here. They're working on I. It is basically you have a circle and some you have a cake and there are some strawberries on it, and Alice likes strawberry but Bob dislikes them, so you need to partition the cake into half with a knife so that all the strawberries lie in one of the cake, and you want to distribute the cakes as even as possible. I think they find the idea of finding convex hole. Let's see what they are doing. Yeah, they are copying the template of geometry. I believe every team should have this prepared in their code book. So yeah.
Yeah. So as Chris mentioned, the code book or their template, in the contest, there's a rule that you can bring 25 pages of A4 sized paper that you can print your reference or code book. So that is some template functions you can print on it and bring it into the contest area. So in the contest, you see some problems like, yeah, that's our prepared codes. Then you can just use it. So that is why this problem is. That is probably why this problem is getting solved so quick, because we did not expect them to be top 5 easiest problem.
Actually, it's one of the problems I solved. I think this is the first or the second problem I solved, because the key idea is actually simple.
Yeah.
You build the convex hull of all the strawberries, and you need to have that convex hull in one of the cake. So basically, you just exhaust all the edges on the convex hull and try them one by one and see which is the better.
Yeah.
What is the optimal one.
So that is what happens if you have the prepared codes for this kind of problems, and this kind of code should be prepared by all teams in their code books. So
yeah, one interesting trick to mention is that in recent years, people, like, as you can see, they are writing template in a separate file. Do you know why do they do that instead of writing it in a code?
Yeah.
Do you know that before?
Actually, for me personally, I didn't really use a lot of code books.
Yeah,
before.
this is a recent trick.
Yeah.
And this trick, they write the code in a separate file, and they can do hash on that file. So they can do a quick check if they made some mistake when copying the code. Because sometimes we mistype n as m, mistype 1 as 2, and debugging on those templates can be annoying. So so that's the reason why they put it in a separate file.
So I have a little story for this. In my last year participating in the competition, I have a teammate who prepared a lot of codes beforehand. So one of the functions, it had around 200 lines of codes. Very complex, but if the problems wants that algorithm, then we have the advantage. The problem is my teammate did copy that function, but he mistyped one of the equal mark as the minus mark. These two marks are adjacent on the keyboard. So now that you have to try to debug 200 lines of your code book to see what is wrong. And that took around 1 hour for him.
Do you want to know something interesting? Fruit Advantage is also working on I.
Yeah, problem I. So
yeah, so the current leaders, the current 5 problem solvers, let's see who they are. Sorry.
Yeah. We have 6 teams that solve 5 problems now.
Yeah,
so
this is
at least 2 teams are working on that problem.
Yeah, what you see on the screen is the Fruit Advantages screenshot. Yeah, you can see they are writing the code pretty quickly.
Yeah, so let's basically
let's browse all the leaders' screen and see what they are doing.
Yeah, so now I think they are now trying to get I think it's input, and then they should start coding the reference. I think they completed the reference, right? It seems like they've already completed reference.
Yeah, they have already. I think this is a part of reference, because this is the Andrew monotone chain trick. They are using the Andrew monotone trick to find the convex hull.
Yeah. Because I just misread the screen, because that screen is actually a little bit far from me. So I thought they were still typing the input part, but no, they have already finished it, and it's now typing the main algorithms part. I think they are now.
They are writing the convex hull.
Yeah, they are now writing the convex hull part. the main algorithms. Yeah, okay. So I think we just had a new submission in, right? Is that
Which
a
one?
new submission?
Which one?
The blue one.
The blue one?
Is that?
No,
oh, no,
no, it's the first,
it's 13
first
first
of
to
B.
solve.
Yeah.
Okay.
Okay, we can move on. Rival Antulet.
So
Screen.
yeah, currently we still have only 5 problems tried by any teams. So
Oh, they are browsing Scoreboard.
yeah, they're browsing Scoreboard, but they should find nothing because they already solved 5 and currently they're
Yeah, they already solved
Yeah.
what others have solved already.
yeah. So
Yeah.
now it is their job to explore on a new problem to see which one should be the easier or lighter to write.
Let's also see some teams from Yangming Chiaotong University, the currently second place team.
Yeah, they are also the favorite. NYCU Cartesian Tree 2. I
Yeah.
think they had.
They are.
I think they had a couple of top 10 performances from last year or before, right? I think they performed really good, really before.
Okay, so they are only checking the homepage. Maybe we can see another team.
Yeah, but they do have the printed problem set, so that's what we cannot see from here, right?
Yeah, they might be looking on the problem set. What are
Yeah.
they doing? Okay, let's see what another team is doing. Okay, this is STEABS, I guess.
Yeah. Wow, they have a lot of files open and indicating a lot of problems they are trying now. So now they are doing, I think it's problem B, right? Is it?
Yeah,
problem
they're
B?
doing problem B. Problem B is a trick problem.
Yeah.
It is a tricky one. Let's see what. Yeah, let's move on. Somniorum Venator.
Yeah,
And
Venator.
see what they are doing. Let's see. Okay. Maybe we can try another team.
Oh, okay.
Okay, let's see Strong Zero from NUS. Oh, they submitted L. It's pretty exciting that we capture this moment.
Wow, problem L. Problem L.
Can
I
they get this
think.
correct? It's pending.
Problem L is I think it's the 8th easiest problem. So it also is the 7th hardest problem in this contest.
Oops,
So
they didn't get it correct.
no, they got. I think it's time limit exceeded. So that means your program consumes too much of time to run all of the input and generating the output.
Yeah, it's time limit.
Yeah.
Yeah, let's see how they solve it. L. Oh, I guess they probably miss it. If I remember correctly, this problem is about a dynamic programming problem, but they approach it with the manner of suffix array.
Problem L. Yeah.
Oh, they might actually have the correct idea, but
Yeah.
they get it.
They
Get it.
got.
Time limit exceeded.
How many test cases do we have now?
I think we have a lot of test cases for this problem.
For this problem, I think it looks like
there are a
around
bunch.
30 test data, right?
Yeah, roughly.
Roughly 30 test data, and they had only one of the test data getting the time limit exceeded error.
I guess they already find the problem, probably because they are writing some extra codes to fix it.
Yeah.
Yeah.
Probably just a simple misread on the problem statements.
I don't think so because
No?
they get 25, like they get 70 or 80% of test cases correct. So I don't
But
think they misread it.
Just one, the largest one.
Yeah.
Yeah.
I think it could also be a problem of constant because even you have the correct complexity, if you didn't implementation it wisely, sometimes you will get an unexpected time limit exceeded.
Yeah. Just like yesterday in the test session, we see one of the teams, they are trying the problem, and one of the check conditions is if A is larger than B, but that team mistakenly typed if A is smaller than B, and that resulted in how many times was it? I think it was 10 to the 9th.
10 million time?
Yeah, around 10 to the 8th or 9th power. So, yeah.
Yeah,
Sometimes one simple mistake could give you unexpected.
Yeah, let's also
result.
move on. Our Japanese contestant from Hokkaido University. They also get 5 problems solved. Let's see what they're working on.
Yeah.
They're checking the scoreboard.
Yeah, people would check the scoreboard frequently because in the first 4 hours of the contest, the scoreboard is live to everyone.
Yeah, it is pretty fast paced. You can see some. Yeah, you can know which problems might be the easier one to approach, and you can work on it first because you want to minimize your penalty time.
Yeah, and to minimize the penalty time is always.
It's critical because there are only 14 problems, it is quite often that we get a tie. So if you want to tie break and outperform the other team, you need to be quick. You need to solve the problem in the correct order.
So it is not only about the correctness or precision. You also have to be quick to all of the problems that you can think of a solution.
Yeah. Let's see. Yeah, 1, 2, 3, 4, 5. Yeah, we only get those 5 problems solved, and I think there are a bunch of teams working on I because if you get the convex trick, you can just copy your code from your reference. Yeah.
So we now have 13 teams, so 5 problems, and two of them are trying L now, and they both got I think they both got a time limit, right?
Let's see.
The team Strong Zero got time limit. Yeah, they got a time limit. They got a time limit on problem L as well.
Oh.
Strong Zero, I think.
Yeah, Strong Zero got that on L, but let me see if there are problems.
Yeah, their summation was one of them got time limit. And the other team, let me check. I think we checked Venator, right? I think we did check Venator. Oh, no. We checked. The team we checked before was Strong Zero. They got one of the test data time limit. And the other team is the Venator. They got a lot of wrong answers. So I think that
who got a lot of wrong answers? I don't think any team get more than one wrong answer.
Venator, they got a lot of wrong answers.
No, that's test case. That's not the number of attempts. It doesn't matter if you get several wrong answers in several test cases.
I mean, they got this attempt had a lot of wrong answers on the test data.
Actually, not quite.
It is one attempt.
Yeah. Like this is a problem between pessimistic person and optimistic person.
Yeah,
from my perspective, I would see 50% of the test cases are correct.
What was in the test data? They got 10 wrong answers here. What was in the test data? They got 10
Oh,
of 30
L getting solved by
just data.
strong 0. I think they successfully used the suffix array idea to solve it.
Yeah, maybe we can take a look at their
yeah.
codes. Yeah, they got the time limit exceeded error fixed now.
Yeah, let's see.
So maybe we can check the codes and yeah. Click on the view, yeah.
Yeah. Oh, I probably look. Oh no, sorry. They used the DP trick. They didn't use the suffix array. I think they copied the suffix array just to be ready for one of the problems, which is edge. Yeah, the edge one requires a suffix array, and yeah, they successfully work on the correct DP idea and solve it.
Yeah,
but
maybe we can show the codes on the screen. I think that 968 was their fix, right?
Yeah, they fix it. They fix it with only a single line.
Yeah.
Yeah, we can show it to you. Show it to the audience. Yeah, as you can see, it is this one single line that cost them one penalty. One wrong attempt.
One time limit exceeded error, the penalty, and also I think
they forget to break the loop, so they run some unnecessary runs, and that cost them additional time.
Yeah, 6 minutes of debugging and also 20 minutes penalty. So that is 26 added penalties on that.
No, you can explain it like that.
Yeah.
Maybe we can move on the scoreboard back and see how's going on generally.
Yeah.
Can we get back to the scoreboard?
So currently we see Team Strong Zero leading with 6 problems and 152 minutes of penalties. That should be quite good for now. But we're expecting other teams that see problem L has a team solved it. They were go and work on that problem. All right, so now we are almost 60 minutes. It's now 15 minutes, 53 minutes into the contest. And we are seeing one team submitting problem J, that is notebook from National Taiwan University. And that one...
Was it yes?
That one was a yes. So we now have 7 different problems solved by any team. And notebook with the first try getting yes on problem J, they are now leading the contest. So you can see Strong Zero took a penalty that's added 20 minutes added penalty. They should have been in first place now, but because of that penalty, they had to settle for a second for now.
Yeah.
So I think people will start to try and work on problem J and L. These 2 problems are, problem J was I think it was the 5th hardest problem in the contest, right?
If I remember correctly, it is a hard problem requiring some data structure.
But they are solving.
Yeah, I think they are very good at data structure, so no wonder they solve it earlier.
Yeah. Chris is from National Taiwan University. Do you know this team?
Yeah, I heard of them before, and maybe we can take a look on this problem. It is an interesting one. Can we move on? Problem statement.
Maybe we can put the size first, just the size, if any.
Size?
Do we have size?
It's okay.
Hello everyone. This is the tutorial of problem B buses. The problem statement is as follows. There are n buses moving in the positive direction. If a person in a bus have the same position, they may hop on that bus. If a person is riding a bus, they may hop off at any moment. All buses move at same speed x. And all people have same walking speed y. For each person, find the minimum time to reach the end of the
Okay, so as you can see in this problem, this is very illustrative. So you have a, oh sorry,
Yeah.
you have a board and you have several tiles on it, and you tilt it to the right and then tilt it to the down, and you're asked the final configuration of this board. So as you can see on the left, if you tilt right, everything goes to the right. If you have played 2048 before, this is something like that. But there are some boundaries that blocking these tiles.
Oh.
So after you tilt it right, you can see on the second figure, and if you tilt it down, you will see that.
Yeah. So there are walls blocking the movements of the blocks. Yeah. So what does the
main idea is to track what tiles are moving to the right, and do it column by column from left to right. Yeah.
so you're given
You're given the tiles and the walls. So for example, in this sample input and output, the 55230 are the tiles, and the 3041 are the walls or boundaries. So yeah, it is the demonstration of the first test cases. The first test case. So 55230, you can see 55230, and 3041 is the height of the boundaries.
So we return to the now we can see the figure. So 55231, 55230. That is our first figure, and 3041 is the height of the walls. So what we want is I think it's the third figures. So 33423 what is our expected output, right? And that is how many blocks in the column we're expecting. So that looks like a simulation problem, right? Just simulate it.
You cannot simulate it in a brute force way. You need to maintain. Some people use a segment tree. Some people use a map or a set. You need to maintain the data structure wisely. Otherwise, you will definitely get a time limit exceeded.
Yeah. So most of the problems here in the contest, you can think of a naive solution, just like I said before. This look like a simulation problem. You just simulate all the required operation you want, but then expect to get a time limit exceeded, because there are always some ways to speed your solution up by some of the algorithms or data structures. So you cannot just simply try to simulate what the problem wants. So that is why the contest or the problems are not really that easy as it looks.
We can also see Venator also solved problem J. Both of these teams are using some methods I guess that were not expected from the judges. Yeah. They use one use let's see the scoreboard. Notebook uses DSU, and Venator are using priority queue, and that's a very neat way to implement the problem. Yeah, brilliant.
Yeah, so that's also why the contest is fun, because
if you find a brilliant move, you can save a lot of time and work on another problem.
Yeah, and also you can see these two teams solving this problem. They are using different ways of thinking and different ways to solve it. So sometimes you can see there are problems you can have like 3, 4, 5 different ways to solve it, and there are different approaches. So maybe we can take a look at
the solution video.
Yeah, the solution video.
Yeah, of let's see.
Maybe
J. J.
Hi.
Maybe we can move on some easier
today I'm
one.
going to introduce
maybe we
how
can
to
create
solve
some.
problem J. squad.
I
How
think
about
I think we can just play J.
So in this problem,
play J? Really? J is not quite
Not really easy?
Yeah, I don't think so.
Okay, maybe we can play
Maybe we
the
can.
easy one.
Yeah.
I just thought
And there are some
we can
vertical
maybe
bars,
just play J
which are
because
placed
we
at
were
the
talking about
bottom
it. But
between
yeah,
each pair.
It's okay.
of
We can
edges.
I think it's okay. We can
So
play
there are
more basic problem first.
n-1
Let's see the
columns.
solution of problem M.
yeah.
We define
M
two
should be
operations.
the
The
easiest
first
one
one
so
is
far that we have not
tilting
played.
right, which
So
tilts
we
all
will return to J when we see more teams solving it.
Oh,
Hello,
I is getting
everyone.
solved.
Let's
Okay,
start
Yeah,
about
let's
the
move on.
problem
But let's do the M
maximum
first.
distance
Yeah.
to port. This problem gives you a connected simple graph G, and all edge have a length of actually 1 unit, and each edge has the product type AI in the integer 1 to 3 to k. For each product type P, we want to find the maximum shortest path distance from Vi to the vertex such that the product type is equal to P. So how to solve this problem? If we just follow the problem description directly, we need to apply k times of any single source shortest path algorithm. This method is too slow, so we can reverse the step. The first step, we can find the shortest path from V1 to all vertex. After we get the shortest path of all vertex, for each vertex Vi, we can update the answer of the product type AI. In this case, we just use one type of the single source shortest path algorithm. So for this problem, we can apply the Dijkstra algorithm or use BFS because each edge has same length. So we can solve this problem in V plus E with BFS, or you can use Dijkstra in this problem, is also okay. Hello everyone, let's start about the problem M, maximum distance to port. This problem gives you a connected simple graph G.
Oh yeah, we can move to the scoreboard. Yes. As you can see on the scoreboard, 4 teams have solved 6 problems, with 8 problems getting solved. Like different teams solve the problem by their by their strength. So you can see STDABS have successfully worked on a geometry problem, and Venator and Notebook worked on a data structure problem, and Strong Zero worked on a dynamic programming problem. Different teams use different strategies. It is quite interesting to see that.
Yeah, because different teams have different fields of strengths, and some of the teams might be good at math, some of the teams might be good at data structure or other fields. So that's why we're seeing like split strategies for the top 4 or 5 teams are using now, because we've seen this scoreboard was almost it almost looked like it's frozen when we have like several teams solve 5 problems. It looked like it was frozen for like 20-30 minutes. So yeah, we can expect teams to work on their strengths now.
At this stage, some teams might get an advantage by luck because they choose the correct problem and work on it, and manage to find that it's actually the easiest one.
Yeah,
remaining.
because again, you need to solve more problems, and then is who solve all of them the fastest. So the teams leading now would have a advantage, although maybe not huge for now, but they do have advantage for later stages of the contest. So now we have Venator leading at 6 problems, but we have total of 8 different problems solved by any team. Now we still have problem K, no teams working on it, because we expected problem J to be a 4-star problem, but K is only 2-star in difficulty.
From my perspective, I personally believe that no team is going to work on K at the early stage, because it looks implementation heavy, but if you really work on it and think about the details, I think I wrote it only in 50 lines. So
Yeah.
it's actually not that long, but when you see expression, you need to do some evaluation on it. You feel like, oh yuck, this is a stack. Oh, this must be very nasty. But if you cool down and think about it, it's only 50 lines of code.
Because I think that problem is quite technical, right? But
Not
you-
quite actually. If it
there are some techniques to like.
not really. You just exhaust all the starting point, all the possible directions, and do it like this. Like for example, you take the grade 2. Maybe you can.
Maybe we can show the problem statements or
Yeah,
exercise first,
yeah,
so
sure,
people
sure.
know what we were talking about.
Yeah, of course.
Yeah.
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 So as we have mentioned earlier in this live streaming, let me talk about this problem again. So you're given a matrix of some numbers and plus and multiplication. Yeah, it only contains of these characters, and you need to find the numbers matching the desired pattern, the desired number. For example, this 7 plus 16 times 45. If you do some math, you will find, oh, it's actually 727. So these two red ones indicate the 727. So there are two of them, and for this one, this should be counted twice because
I think it's 3, right?
yeah,
The answer
because
is 3 for this one.
yeah, this one
Yeah.
this one should be counted twice.
Yeah.
So
Left to
if
right and
yeah,
right to left.
Yeah, so it's 3 for 727.
Yeah.
Yeah, and the trick here is you can take one starting position and one direction. So for example, you have 5 and 5 plus, and it's not an invalid one, and 5 plus 7 is 12. And when you do 5 plus 72, what you actually do is you multiply 7 by 10 and plus 2. So you need to maintain the last term, the multiplication thing of that. So you need to do like 7 times 10 plus 2. So you can like doing some O1 update to maintain what the expression is evaluated to.
Yeah. Again, it's you cannot just solve it by naive, try to look all their rows and columns and start from any point. You have to do some speed up, just as Chris mentioned, to really solve the problem. So that is what the problem's hardness is at.
Yeah, maybe we can move back to the scoreboard.
Yeah, probably people are not really. They might be not working on this, or they probably have not haven't had an idea of. Yeah.
Yeah.
So now.
Meanwhile, as I mentioned earlier in this live streaming, there's also a coforces mirror that if you're interested in those problems, you can take a look on that.
We have some team solving 8.
Yeah, we have teams solving 8 problems in coforces mirror.
Maybe we can show them the address in case some people want to see it. Maybe we can just pull the.
Yeah, we can pull this down.
Yeah, so you cannot. So you can now check the address, and you can see there are some. I think that there's a team.
Yeah, just use CRT and for some, I think they played in the Bangkok regional a few weeks ago, and there are also pretty strong teams from South Korea.
You can see 3 red IDs. That means they are grandmasters, right?
They're probably international grandmaster because they don't really
check.
distinguish.
I think they are international grandmaster.
Yeah, there are 2 possibilities.
International grandmaster or but anyway, they had the grandmaster title or international grandmaster title. They should be pretty strong because so for now we can see in coforces if you have a red, then it means you are at this rated 2400. So
But sometimes it's a bit unfair to compare the actual contestant with those mirror contestant because
Yeah.
mirror contestant can copy codes from their local computer.
They can just copy it.
They don't need to type it.
They don't need to type it.
Character by character.
Yeah. So sometimes it's unfair, but you can use it as a reference.
Yeah.
And
K is getting solved.
Problems K strong 0 is
Leading the contest by solving K. Let's move back to the
with a pretty
scoreboard.
low penalty. So I think they did recognize that speed up, and they managed to solve it. So now we have total of 9 different problems being solved, and we're now at 70 minutes mark.
Yeah. Let's see if the problems have been solved. How the problem has been solved from strong 0. Let's see. No, this one.
Yeah.
Yeah, they solve it by times 10 and plus that.
Maybe we can show the codes, because the code looks quite simple.
No. It's not that simple. It is 2 blocks.
It's not that simple?
It's 2 blocks.
I missed the other one. So I only saw one of the blocks. It looked really simple, but the other block, it's not the case. Yeah.
Actually, both of them are simple, but when you combine them together, I don't think it's quite that appropriate to show it. Oh, actually, it's also getting solved. We have, it's so crazy.
Like, yeah, wow. 5 different problems.
5 different problems, yeah. People choose to be the 6th problem to solve. It is a rare scenario to witness.
Yeah. So maybe we can check the scoreboard. We can show the scoreboard.
Yeah, we were already showing.
Show this one.
No, it's okay. We are doing live streaming.
Yeah, but people cannot see the top teams now.
They can see in the ticker.
Yeah, they can see in the ticker, but not.
They can see now.
Oh yeah, they can see it now. So we have 5 different problems, HIJKL, being solved by top 16s, but only 3 of them solved 2 of them. Yeah, that's interesting.
Yeah, and even those 3 teams, like the top 6 teams, are solving different subset of problems. You can see the strong zero is solving K and L, and Venator is solving J and L, and STDAB is solving I and L. Yeah, and PC Commerce is solving I, Notebook solving J, Revel and Hewlett solving H.
Yeah, so. Okay. So
and you can see Fruit Adventures, who also solved 5 problems, is now working on D.
They're working on D now?
Yeah, as you can see on the scoreboard.
Can we check their codes? Or I think they got
that one is too hard.
2 attempts of wrong answers. But problem D, I think, is one of the hardest problems we're expecting, right?
Yeah.
I think it's hardest or second hardest?
They think they are tied, but personally, I would say D is the second hardest.
Yeah. So.
Yeah. Maybe you can take a look at the chat room. Can you take a look at the chat room?
Chat room?
Yeah, it's too far. I cannot quite.
The chat room.
Yeah, what's over there? Hi chat. Okay. Hello.
Hello chat. Waku. Hi chat. CRT or what is the CRT?
CRT is the team from South Korea. Just use CRT from Coforces.
Oh yeah, CRT is from the mirror, right? It's from the mirror.
Yeah, it's from the mirror. They solved 8 problems
at 186 penalty.
But they solved 8 problems within only 15 minutes.
Yeah, but once again, you cannot directly compare people doing the mirror contest, because they had another advantage is they could use 3 computers to do the task at the same time, but our contestants in the contest area, they had only one.
Yeah, but
they got
when
only
we're
one
doing
computer.
when we are practicing on code versus, we actually only use one computer. So I guess just use CRD
Yeah,
and
maybe
for
they're
some,
doing the same.
Yeah,
Only
because
one
they're
computer.
the contestant of this year. I don't think I think they want to
Yeah.
practice as much as possible. So,
So,
I think
yeah,
it's
so
very likely that they use only one
only one
computer.
computer. Then if they are here, that is a very huge lead, because 8 problems, 186 minutes is one problem more than the current leader, and also less penalty. So should our leader solve a problem now? I think we're at 76 mark. That would be 8 problems and 296 minutes of penalty. So that is already 110 minutes disadvantage to our mirror leading team. All right. Now we are seeing some. Okay.
Maybe we can also
yeah.
take a look at some other teams. But
Solutions?
let me no. Yeah, we can take look the
No,
solutions first.
they're trying. What
depends.
problem are they working? What's this?
I don't know which team this is. I'm going to.
I think that one is a convex hole. They did it conf.
Oh yeah, I guess
C++.
it could be.
But
convex
that
hole.
could be a reference.
Yeah,
Yeah.
I think we can also check some teams from other universities that also agree on being screencast.
Yeah.
Let's see. Which problem do you want to pick? Which university do you want? Yeah. Are you interested in?
Maybe we can check Keist. Are they
Keist? Okay, sure.
Keist? I think is. Yeah.
Yeah.
Because I think they were leading in early stage, but now it seems they are facing some difficulty.
Let's see what they are working on. They are working on the convex hull. So can we move on the screencast? Yeah, they're working on convex hull. I guess this must be I.
Yeah, it should be, because that's the only problem. I think we need the convex hull reference. Yeah. So I think they are just typing the reference now, right?
Yeah, they just finished typing it.
Did they finish it?
Yeah, I guess they finished it.
Yeah, look like. Because 1-2 minutes ago, when I was checking, they were still typing the reference. So we can maybe expect they soon will be one of the teams that solve LX6 problems. Currently, we have 6 teams solve LX6, and 3 of them solve 7. Yeah.
Let's also move on some random teams to make this more exciting.
Yeah. Maybe we can check.
Let's see. Okay, this team from Fengchao University is working on M, and yeah, they are writing BFS. I think they get the right idea. It's just a matter of time.
Yeah.
Yeah, and we can also see some random teams here.
Maybe something from Formosa, or
yeah, I'm taking the teams from Formosa.
Yeah, maybe
copy
Formosa.
the URL. Yeah. Oh, they are looking the scoreboard.
Yeah, they're checking scoreboard. So
okay, let's see some other team.
Maybe they are in the midfield and they want to know.
Get some inspirations from the scoreboard.
Could be easier, or yeah. How about
let's see Hokkaido University?
Yeah,
I'm going to take a look on that.
A Japanese team.
Oh, they are also working on convex hull. Like convex.
So people recognize it, and people are now.
Upon reading, I think most of the teams get the idea, but it takes time to copy the code from your reference book.
And we can see Venator in second place. They are also trying that problem, but they got, I think, they got their program rejected, it was a wrong answer.
There is a trap in this problem because
Yeah.
there's a tricky case where there are only 2 strawberries, and if you do the convex hull on that,
Yeah.
it doesn't necessarily form a thing,
Yeah.
a convex hull, or
Yeah.
all the strawberries are formed in a line,
Yeah.
and in that case you cannot. Yeah, you need to. It is a tricky case to
it's not
consider.
really a convex hull or a shape from that. It's only a line. So let us one of the edge cases or the trap you have to think of and think about.
Yeah. When we are testing the problem, we also get trapped into this tricky case, and
Yeah.
it also costs us some time. Okay, they are reading problem B. The screen you are now currently looking at is from University of Taipei, the BOGO sort.
The Bogle sort.
Yeah.
So
Let's.
yeah. I
Just-
think problem B is not really that easy.
I don't think problem B
mid-
is quite easy.
Yeah, it's
Problem
not
B
really that
requires
easy for
a key
midfield
observation.
teams. Yeah. For midfield teams, I think it could take some time for them. Bogosort is now currently at 44th place with 4 problems solved.
Okay, the screen you're currently looking at is from National Tsinghua University, the LCS and
LCS?
yeah.
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 They're just one position higher than the Bogosort now. And are they trying problem B now?
Yeah, they're trying problem B.
Yeah, problem B.
And let's also take a look at Institute of Science Tokyo, the Tsukuyo one. Yeah, they are also working on B.
So people in midfield are all, maybe all of them, almost all of them are working on problem B.
Yeah, but B requires a key observation. Don't get stuck too long because
Yeah.
some teams might find the idea, but if you didn't find it, you will struggle a lot. So yeah, if sometimes when you didn't find the right idea, it's important to like take a temporary abandonment and move on to another problem.
Yeah.
And what you see here is the screencast from Teleology from National Taiwan University. They are also working on problem I, the convex hull problem.
Yeah, so people in the top maybe 10, 20, or even 30 teams, we already have 29 teams solving 5 problems. Maybe most of them are working on problem I, because if you, like we just said earlier, if you have the convex hull in your reference, then this problem can be very easy. But to get it right, first you have to also take care of the edge case, where all of those points form only a line, not a shape of convex hull. So we now see PC Komaki trying problem K. Is that a yes? I think they
Yeah.
got a yes. So they are now the 15 to have 7 problems solved, and they are now in 3rd place.
Yeah, do you want to take a look at PC Komachi's screen?
Yeah, I think we can take a look at
Yeah.
their screen. Are they trying problem? What problem are they trying now? It's a little bit far from me, so I cannot really see.
Yeah, they managed to solve K and join the leaders of those 7 problem solvers.
Yeah, so now
Yeah, it's quite interesting. They
yeah.
also solve another subset of problems.
Yeah,
Yeah, they solve I and K.
yeah. So, yeah, but I is convex hull. I think most of the top teams would solve it.
Eventually.
Yeah, eventually, and maybe even pretty soon they will all solve it. But now it's quite interesting to see what teams are going to work on. I think maybe HLJ, because teams they should be
H and J
they should start to work on L.
are harder problems
First.
according to the judges.
Yeah, but it is one of the harder problems. So split strategy, but error I think is 7th hardest. They could be working on it. Is this their screen now?
Yeah, it's the screen
So-
from PC Komachi.
So they are not doing any.
They are not coding. I think they are
they're not doing
working
coding
on
now.
ideas.
So maybe all 3 team members are working on some problems.
Yeah, let's see what the current leader is working on.
The Team Strong Zero from National University of Singapore.
Yeah. Yeah, let me see. They are working on I.
Problem I.
Not quite a surprise.
Yeah. Also the canvas hole, and it's one of the more teams solved, but they didn't solve it. So yeah. At the same time, we're seeing Venator's got 2 tries on I, and both of them are rejected. Again, they have only one of the wrong answers. I think that is the case. We have only 2 points, right?
What do you mean?
The Venator's second attempt on I
Uh-huh.
is another wrong answer on same test data. It's on the same test data.
Yeah.
I think that one is,
Yeah, I think that's a corner case
yeah, that's one of the edge cases.
where they are expected to output pi over 2, but they output pi.
Yeah. Yeah, pi over
Yeah,
2.
that-
That one is the case that we have.
Yeah, we mentioned earlier.
Yeah, we mentioned earlier. Yeah.
Okay, maybe we can move on another solution video, just in case that some audience is interested in the solution.
Yeah.
Let's see. Let me see. We have played E and M, and maybe we can talk about F.
Yeah. Yeah, I think we can play F now. So
Yeah.
Hello everyone, this is the solution to problem F, cluster computing system. Let's review the problem description. You are given a
yeah, we can
weighted
play F now.
undirected complete graph. The weight of the 2 vertex Vi and Vj is defined as the range GCD from Ai to Aj. You are asked to find the weight of the minimum spanning tree. How to solve this problem? We can first make the observation. We should always use the age 1 to n. Because 1 to n have the global minimum GCD among all numbers. Therefore, we should always choose the minimum ages. The age have the minimum weight. So, there are a second observation that for all ages L and R, such that L is not equal to 1 or R is not equal to n, are useless. Why they are useless? Think about that. L and R should be connected to 1 and n, right? But 1 to R has a GCD that's not greater than LR, so as L to n. Therefore, the age LR must be replaced by 1 of 1 to R or L to n. Or you can think about the cycle property of the MST, because 1R to L to n and back to 1 form a cycle. And LR can be proved to have the maximum GCD among the maximum weight among this cycle. Therefore, we can always remove HLR. So the answer is a simple formula. You should calculate the range GCD from 1 to n first, and then sum over I from 2 to n minus 1.
Hello everyone. This is the tutorial of problem B buses. The problem statement is as follows. There are n buses moving in the positive direction. If a person and a bus have the same position, they may hop on that bus. If a person is riding a bus, they may hop off at any moment. All buses move at same speed x. And all people have same walking speed y. For each person, find the minimum time to reach the end of the road. The key observation is that each person only needs to ride at most one bus. If a person rides 2 or more buses, then the finishing time only depends on which bus is the last one they ride. This is because bus schedules are fixed, and after hopping off the last bus, the only thing to do is keep walking. Let's use the following example. The person rides the green bus, get off the bus at time 0.5, then ride the red bus. We know that the red bus will reach destination at time 1.25, so the finishing time is 6.25 regardless of the schedule of the green bus. It remains to show that if a person rides 2 or more buses, then it is always possible to only ride a specific bus among them. This is because all buses move at the same speed. So riding a bus does not help you to catch another bus that you initially couldn't ride. Refer to the following picture. The person cannot get on the yellow bus. Even if they try to take the red bus first, it does not help the person to catch the yellow bus. We will now describe the algorithm. Suppose a person is at position P and a bus runs from position S to position T. The person can ride the bus if S is less than or equal to P because buses are faster than people. If the person takes the bus, the person is effectively walking from the position as shown without the bus. In this example, P equals 3, S equals 0 and T equals 5. Then taking the bus is equivalent to start walking at position 3.75. For each query position Pj, the task is to find the bus, Si, Ti, satisfying the conditions as shown. If Pj is larger than this value, then the person will not take any bus because it is fastest to simply walk. The answers can be calculated by looking all Pj and Si in ascending order. For example, red bus has value 3.75, green bus has value 3.5, so the boy at position 3 will take red bus, while the girl at position 5 will not take any bus. The yellow bus has value 8.5, and the man at position 8 will take the yellow bus. Time complexity is On plus M log N plus M. We conclude with some final notes. It is possible to do most computations using only integers and leave the division to the last step to avoid the precision issues. The insight of this problem is that sometimes you can skip a bus, or metro, without changing the time to your destination. For example, if you want to go to Taipei 101 from Taipei Main Station, but the current metro stops at Don Station, then you may wait for the next metro instead of getting on and off the metro twice. Thank you for listening and hope you enjoy this problem.
Okay, so now we're back, and
Yeah, I will also play the solution video of B. And at that time, very excitingly, Strong Zero have solved problem N.
yeah, problem N, and that was one of the, I think it was, the judges expected to be the fourth.
One of the hardest
problem.
problems.
Yeah, one of the hardest.
So now we have 6 problems getting solved, and for those teams that only solve 5 problems, they have 6 choices to go for.
Yeah, and our top 5 teams have 6 different problems solved, but only 2 of them have managed to solve 3 of them. So we can talk about The 60 and 90 minutes heuristic now. So it basically is in the previous editions of the contest in Taichung regional, we have some patterns that we observe, and in the past years, when we see, like, for example, 7 problems in 2020 were solved uniquely by all teams at 90 minutes. That year, the gold medal line, which is the 10th place you can see on the scoreboard, the rolling scoreboard here now, the cutoff is at 7 problems. And the next year, 8 problems uniquely solved by all teams. The gold medal run was 8 problems. So that was the. We have no, let's say, how to say that? We have no.
What do you mean?
We have no exceptions in all of the previous editions. So currently we have 11 different problems solved by all teams. Maybe we can predict the gold medal run should be at 11 problems. So for the top 10 teams, we only have 14 problems this year. So maybe the winner will have to solve all 14 of them. Is it possible?
I think the problem G is quite hard, and I guess the champion would be 13 solves, but I think the second place will also have 13 solves.
So that means we could have a tie on problem solved in the top
I'm not sure.
two,
Maybe
but
it's 13 to 12. 13
maybe
to 13 or
12.
13 to 12.
Last year it was 13 to 12.
Yeah, last year it was 13 to 12.
Last year, yeah. But last year our third place only had 10.
Yeah.
But gold medal line cutoff is at 9. So maybe 13-13, and we will have to break the tie by penalty, or maybe we have a 13-12 condition. Yeah. So the other thing is, at 60 minutes, we had 7 unique problems solved, and that in the previous years is the cutoff at 30th place for the silver medal. Again, only one exception in 2021. So we can maybe expect silver medalists to solve 7 problems. That is also quite a lot.
Yeah, we can see Vanisher send a trial
they got a 9th.
C.
Yes? No? They got no. So yeah,
It looks like they might. What? No. Yeah.
Yeah.
I think they missed some cases.
Yeah. They got 4 wrong answers on that attempt.
I don't think it matters a lot about how many test cases they pass and fail.
You got
it doesn't
1
matter.
wrong answer is wrong answer. You got 10 wrong answers, still wrong answer. It's the same. So they are now working on C and I, but both got rejected. The I is the 3rd time they got rejected. I think it could be the same case again. It should be the same case again.
It's the same case.
It is. So that is already cost them 3 penalties and probably 20 minutes. Another 20 minutes. So that's 80 penalties.
Yeah, Strong Zero just printed out code.
Yeah.
We can talk about printing codes.
Yeah.
So teams are allowed to print codes so that they don't occupy the computer in case that their teammates want to work on another problem. They can just print out codes, read the code on the paper, and find if there are any bugs. And once they spot it, they can just tell their teammates to say, "Hey, I've find a bug," and please yell the computer to me, and
Yeah.
after I do the debugging, and it could be quite time saving.
Yeah, and also printing out the codes is one of the, I think, important ways
Strategy.
to do the debugging, because when you print all your codes out and you do all the debuggings on it, usually you would just try to solve all of the potential bugs, and maybe even do some optimization on your codes, and then you have all your intended modifications on it. You will just do it at one go, and usually you can get a yes unless you really misread the problems like heavily. All right, so maybe we can
take a look at our
yeah,
two leaders.
Yeah.
Yeah, we have Strong Zero and STDABS both having 8 solves. We can switch to a screencast.
Yeah.
Yeah, and let's see. So this is the STDABS screen. They are working on K. It looks like they get the right idea of iterating over all the possible starting positions, and also iterating all possible 8 directions, and just work on it, and do it.
Yeah.
Do some dynamic update, and you can solve it in a very efficient manner. Okay, we can also take a look at Strong Zero's screen and see how these two leaders are doing in the contest. Okay, so they're working on the convex hull, which has been solved by the top teams mostly, and I guess they might manage to get it correct. Okay, if you're an audience from YouTube, you can also comment which team you want to see, and we will see if we can switch to their screen and share it to you.
Yeah, provided that if they have agreed to share the screen.
We have do some investigation beforehand, so that only teams that agree to be screencasted will be displayed in this live streaming.
At the registration, we have surveyed all the teams if they agree to share their screen during the contest. So yeah. There's a comment, is a ballot once again. What's that?
Like
ballot. Is it a
ballot
team?
is one of the famous problem setters in recent years. So they saw a problem solution video and saw that problem setter again.
The problem setter. We had the names of the problem setters in the slides and the videos. Yeah. So
he said a lot of problems recently.
Yeah. So starting from last year, this time in Taichung, of course, the Taiwan's regional contest, we have a call for task that is everyone can submit.
Scoreboard.
Everyone can submit a problem, and then we have judges, and the judges are like a lot of retired contestants or professional problem writers. They will take the problem and try to optimize, and they think of the test data. And also we have problem testers. They can also provide some ideas to that. So we have a professional team to do the job, but still we give credits to our problem setters. So that's why we have I think we have problem authors or setters and also the tester in our slides.
Yeah. They will be revealed later in the closing ceremony. Stay tuned.
They will be revealed later. So NYCU Rosalia is now submitting problem B, and that one is a yes. from moving from bronze to silver.
We can also take a look at the Coforce's mirror, how it's doing now. Let's see if we already get 10 solves or what? Wow! Just use CRT solves
There are
already
at
10
now.
problems.
Yeah.
We can move on the
Yeah,
Coforce's webpage. Yeah, we can see
They got
just
10
use
now.
CRT has already solved 10 problems by solving A, B, E, F, H, I, J, K, L, M.
And another Korean team should be in our contest. They will also be leading the contest now. They're with 8 problems and 259 minutes of penalty. Current contest leader is at 309 minutes. So these two teams, if they are in our contest, they would be leading.
Yeah.
And in our mirror contest, the third place is a
single player.
Yeah, I think it's a single.
Yeah,
Sing-
a famous
sing-
Kason.
Yeah, case. I think is he in the top 5 in our Coforce ranking?
I'm not quite sure.
Let's check. I think at least we are sure he is in top 59 because we only have 59 people above 3,000. Yeah, so he is actually our fifth
STD
ranked.
ABS get 9 solves. They're
Ah,
yeah. It's a comeback from STD ABS. They are currently leading the contest.
They solved problem K
Yeah, they solved by solving problem K.
at first try. Yeah.
Yeah.
So 9 problems for 71 minutes of penalty. Yeah. K-Sum 48 in the mirror contest third place is the
Scoreboard.
fifth place in the Coforce rating with 3655 rated. Yeah. Let's get back to our scoreboard and we can see STDAB is leading
contest after solving problem J. K.
Problem K at 105 minutes mark. So they have almost 200 minutes to try to solve other 5 problems. 2 of them were solved by our teams, so they should be working on those 2.
Yeah, let's
now.
see. Let's see. They're working on H or N first.
Yeah. Is it H or is it N?
H or N. Yeah. Let's see.
STD ABS.
Yeah, we can switch back to the screencast.
It looks like it's H.
It's H, and they find the idea of using suffix array SAIS. So I guess they will get it correct soon.
Should be. Is there any trap in this problems test data?
Trap? I don't think so. But if you don't approach in the correct angle, if you think it too complicated, you will be writing a lot of codes. But I guess using SAIS is the right idea to this one.
Yeah, because this problem, the input and output is actually, it looked quite simple. I mean, looked.
Yeah, we can talk about that problem.
Yeah,
it's just about
just show
some poker problem.
Yeah,
yeah.
Let's just show the simple input and output first, and then we switch back to talk about the problem.
Let's see what it is.
How easy it looked like.
No, it's not easy.
Yeah, I mean, looked like. How easy it looked like in the simple case, but it's actually not easy at all.
So I can explain the problem a bit.
I think let's see the simple first. Simple.
Yeah, here it is.
Yeah, every case only 2 lines of input and 1 line of output. Looks easy.
Yeah, okay, sure.
Yeah, okay, then we switch back to...
Okay. So the problem is about a poker problem, and here we define 2 ways of shuffling cards. One way is to shuffle the cards by riffle shuffling. If you play poker a lot, you must know what riffle shuffling is. As you can see here, it is you split the card into 2 stacks and then put it one by one. So here we can get the shuffled card can be shuffled deck can be expressed as this one. Like you place the first card from the first deck and then the first card from the second deck, and the second card from the first deck, and just using the pattern like using this gesture to shuffle the cards. Yeah, and there's also another way to shuffle the card is cutting the deck. You just having the deck having M cards from the top and the remaining in the bottom, and you place the suffix to the prefix. These are the 2 operations. And problems is asking you to find can you do a good way to cut the deck, and then after those operations you can get lexicographically smallest deck.
Yeah, so like how you can cheat to get what the problem wanted.
For me, when I solve this problem, I saw K is it is always the number of cards is always the power of 2. So I wanted to find the pattern of what is the period of the identity. So if I do riffle, how many times after that we will get the identical permutation? Yeah. And when I try to do some simulation, I can find that actually after K riffles, you will have it return to the initial stage. Yeah. So this T is just a bluff in the technical specification. You can having T modulated by K. Yeah,
and then there's a simple simulation.
Yeah, it's effectively the same, but the remaining part is still a bit hard. You need to find what exactly are them during those shuffling. Yeah. And if you find some patterns, you can do something accordingly using SAIS and solve the problem. Yeah, let's see if
so
the team.
Yeah, and the teams that know SAIS will have the SAIS algorithm in their reference.
Yeah.
Yeah. So the teams that have this in their reference will also have advantage. But this again is one of the I think more popular algorithm that the teams will put in their reference for the top teams.
Yeah, I think some teams will use the pure suffix array, but some teams are using SAIS. Yeah. SAIS is runs faster, but the code length is generally longer.
Yeah, it's generally longer. So that depends on the team's choice. Do you want to code it faster, but maybe without the reference, or if you want to just copy from your paper printed reference, so you have to type it all, but it's longer, and maybe takes, I think, 1 or 2 more minutes of the penalty.
I think it takes longer than that because
maybe even longer. And you have to be very, very cautious when you try to type it.
Yeah, but they use hash now, so they don't necessarily get tricked when they type it incorrectly.
Yeah.
Let's see the judge queue a bit. Yeah.
Yeah, most of the top teams they use hash.
Yeah.
Most of the top teams, but for the midfield teams or even the teams at the bottom of their ranking table, they might not know this technique. All right, so now we can see they're doing problem H. Did they finish the algorithm? I think.
Yeah, they are still copying.
They're still typing it.
Yeah, maybe we can move back to the scoreboard and see what's on the table.
Yeah, they haven't finished it. Yeah, it's quite a long algorithm. Quite a long codes. Okay.
Yeah.
Yeah. So now we see 61 teams solve at least 4 problems. That means our bronze medal line is now at least 4, and with some speed.
I believe Strong Zero is going to solve I soon because they have. Last time we checked their screen, they already
started.
They've already started it. But
yeah,
but maybe we can check some other teams first. Let's see the Venator.
yeah, Venator. They're still. Are they still doing C and I? Because they got 3 wrong answers on I. All 3 attempts are.
Or maybe we can see PC Komachi.
Maybe, yeah, Komachi is a good idea too.
Wait a second.
Komachi, I think they are now at in fourth position.
They're in first place.
All of their attempts to the first 7 problems solved were accepted in first try. So, 1 try accepted, 1 try accepted on all the problems.
Yeah, let's see what they're working on. They are working on L, I guess.
L. Yeah, L is.
Yeah.
What was L?
The dynamic programming problem.
Oh, yeah.
Venator solved I.
So they got it. They
got
that
A
case.
solves.
They got that case
They
correct.
get the corner case correct.
Yeah. After how much time did they take for that one? So they took 36 minutes to debug that case and also 3 penalties.
Yeah, but they managed to, as long as they managed
Yeah,
to get it correct, is a good.
Yeah, the most important
result.
is they got it right. Although 96 more minutes of penalty, but the most important thing is 1 more correctly solved problem. So now we have 3 teams solve at least 8, and STD ABS leading by 9 problems. Leading by 1 problem. They have 9 in hand, leading by 1 to strong 0. But right now, strong 0 still have the penalty advantage. Should they solve a problem now?
Let's see. Some teams from other universities.
Reventulate or notebook, or maybe for advantage.
Or do you want to see some? Yeah, maybe you can also take a look at some teams from other universities.
Some midfield ones. Maybe we can see. Did NTNU to beat down agree to share their cast?
Which one?
NTNU to beat down. They're currently in 13th
NTNU?
place. NTNU and number 2, the number of 2 and beat down. Number, yeah.
No.
They did not agree. Yeah, okay. How about Akai Koibito from Hokkaido University? Akai, AKAI. Yeah, Hokkaido University.
There's 2 teams from Hokkaido.
Yeah, the second one. Yeah, this one.
Okay,
This
sure.
one. Maybe we can check what they are doing, because they still only have 5 problems solved. And
I don't think 5 is the only. I think solving
we
5 problems is great.
5, but to
5 problems is great.
Yeah, but to their standard is quite low, because you can see their last.
It doesn't matter. Like I think 5 problems is good enough.
But their last accepted attempt was 1 hour ago.
Let's see
minutes.
what they are doing.
Yeah, let's see what they're doing now, because they could be working on like 4, 5, 6 problems at the same time.
It looks like they are solving some quadratic equation.
What is that problem?
It's I, but let's see. They want to find the circle line intersection. But yeah. That's one way to do it. Yeah, because you need to find the area of the cake. So one way to do it is finding the intersection of the line and the circle. But there exists an easier manner to do it by just checking checking the distance between the center of the cake to the edge of the convex hull.
Yeah.
But this one also works, probably.
It sounds it should work.
Yeah, let's also check some other teams. Like, let's randomly move on some different teams. I'll be interested to see.
NTHU Steinsgate, did they agree? Or Brooklet Frontier? They
Let's
did
just
not?
let just randomly pick some
Oh,
from
okay.
those agreed
Okay,
list,
yeah.
because yeah,
Providence, the Avenue Mujica, maybe? Or where is South?
yeah, I'm going to display where's south.
Yeah, where is South?
Where's my mouse?
Yeah. Where is South, they also have 5 problems solved, and
They are also working on the circle line intersection.
also the problem I.
Yeah.
So everyone's
Yeah,
looks like everyone's working on
as
problem
long
I
as you
now.
see problem I think
Yeah.
some teams would get a rough idea on that, and it would be quite exciting to give it a try.
Yeah. The only trap for that one is the
Yeah, the
2
collinear
points.
case.
Yeah. Okay, we're seeing Komaki getting the, what is that, wrong answer on problem L. Is that wrong answer? It is wrong answer. And lots of test has got wrong answer, so yeah. Nowhere close to get it accepted. Still, we have the leading team only.
Let's
9.
see fruit advantages.
Yeah. Fruit advantages. The one.
Yeah, this
yeah,
one.
this one. The National Taiwan University team at 7th place.
They are working on, let's see, they're working on J.
Yeah.
They want to do some divide and conquer on this problem.
J.
Yeah.
Did our judges expect that solution? J.
I think so. That's also one of the intended solution.
Oh yeah, maybe. Okay, so we're now 2 hours into the contest, and first team, I think the leading team is still at 9 problems. 5 to go. 2 of them should be solvable by then. How do you see problems C, D, and G?
I think, honestly, those is personally, I think D, G is harder than C is harder than D. But the judges believe that D is harder. So let's see which problem gets solved.
Yeah,
Do you want to-
they believe D
do you want
and
to make a
G
bet?
are the hardest problem. Yeah. But I haven't really seen these 3 problems. Well, I've seen them, but
Yeah, we can guide them.
I didn't have much time to think of this problem.
Yeah, we
I
can
had-
guide them.
yeah.
We can also bring them to the audience.
I had only checked the problems at once last night, and only 30 minutes for me, so I didn't really have time to think of all the problems. I managed to solve first 5,
Oh,
but yeah.
yeah. Maybe we can explain it once some team get it correctly.
So yeah, problem. Which one? C? No, it's not.
Do you want to see problem C? Yeah, I can explain it to you.
Yeah.
So
we can put problem C statement
yeah,
on
let's
screen.
put it here. I've bring it here.
Yeah,
so
it's one of the hardest problems in the contest.
I think I can make it shorter. So basically, you have some circles, and you need to put it on a line such that these the points, the distance between the circle, the minimum distance between the circles are maximized.
I'm maximized. So how many circles would there be?
I think there are 200K. If I remember correctly.
200K
No,
circles.
10K, 10K.
10K? Yeah, 10K circles. So
Yeah, and you need to place them on a line, shown in the figure C1.
yeah.
You need to put them such that the circle does not intersect, and you want to maximize the distance between maximize the minimum distance between circles.
So is there any limits because the maximize the minimum distance we can yeah.
The restriction
you
is
maximize the minimum.
Yeah, you maximize the minimum.
Yeah, so there's already a limit here.
Yeah.
You cannot just put them everywhere far from each other because the minimum.
Yeah, and beside that, you can
Yeah.
only place it within a line of, I believe it is L. Like there is a parameter L, and you can only put it within from 0 to L on the x-axis.
Yeah, so you cannot just put this 0, that one at maybe.
Yeah,
that's you
a
cannot just
restriction.
put it. Let's say this one on Earth, that one on Moon, that one on the Mars. You cannot just do that. So there's a limit.
Oh, sorry. The maximum distance between the centers is k, and L is another parameter specifying that the number of circles that may or may not be enclosed by other circles. So there's also one additional constraint that some circles cannot be be enclosed by others. So it needs to be placed at the
Outside.
Yeah, the outer. It should be the outest one, the
Oh,
most
so-
exterior one.
So there is one circle, the biggest. Let's say maybe
Yeah,
the biggest one.
The L circles cannot be placed. The L largest circles cannot be placed within another circle. They need to
Ah,
be placed
yeah,
there.
yeah.
Like placed
So-
separately.
So yeah, okay. So
They cannot be enclosed.
Problem C.
Yeah, we can take a look at some other screencast, or maybe we can also take a look at Scoreboard.
Is
Yeah,
it
NYCU illustrate
River Starlight? River
River
Starlight. Yeah.
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 It's
Again,
free-for.
the screen is pretty far from us, so sometimes we misread
Revision
it.
test. Oh, PC Komachi solved L, and they also joined 8 problem solvers.
Komaki?
Yeah.
8? 8. Yeah, they are 8. They're back to third place now. So yeah. So next one they should be working on.
I guess they must be
guess-
working at J.
Yeah, I guess that should be J. All right. So for the problem C,
PC Komachi is a very messy team. They have 2 members from the IMO selection camp. So yeah, they are a very messy team, and it is reasonable that they work on a data structure problem later because they might have some other strengths in other problems.
for problem C, is it possible to do it by some greedy or?
Yeah, you get it correct. Like the trick is,
I think.
yeah, you need to.
Could be greedy, but
Yeah.
maybe very tricky.
Yeah, it is something about greedy algorithm.
I think greedy is possible.
Yeah.
Yeah. So did the judges expect greedy or maybe any
Yeah,
other?
greedy is one of
approaches?
the modules in this problem. Like you do binary search,
Yeah.
and in each search you might need to do greedy so that you can check if that threshold is feasible or infeasible, and you just narrow down the range of your binary searching.
So basically, you let the computers to do some computations that you are not going to do by yourself, and then you provide some answers, possible answers.
You want to inspect a threshold if
Yeah.
larger than that. If larger than that is feasible or not,
Yeah.
and if it is not, it
Yeah.
implies that it should be the upper bound,
Yeah.
and you can keep doing this and narrow down the ranges.
And you eventually will get a answer.
Yeah, you will get a
correct answer.
small enough answer.
Yeah.
And one of the key observation in this problem is that you are not allowed to output floating number. You can only output a
integer.
rational number.
Rational.
No, a rational number. Yeah.
Yeah.
So as you can see, maybe you can switch back to the problem C again.
Yeah.
Let's see.
Yeah, I see in the sample output 4 there is a 10/3.
Yeah.
Yeah. Maybe we can show it
Yes.
to
We
the
can show
audience.
it to the audience.
Yeah.
Yeah, so
Example
you need
4.
to find A and B such that the answer and the answer and your output difference is minimized. Yeah, so you need to find a rational form of that. And some would think that we might need to use Stern-Brokat binary search, but actually this is not the case, because if you do some math, you figure out that the denominator should be bounded by n. So you don't really need to do some Stern-Brokat nasty trick. Just binary search on some limited denominator.
How many teams would put this algorithm in their reference?
I guess I'm not quite sure, but
10?
some teams
Maybe
would
10?
have binary search prepared, and they will also have the Stern-Brokat tree. Like Stern-Brokat tree helps you to find when you want to do binary search on fractional number, and it is a good template to use.
Yeah, it should be. So, but I still think not too many teams would put that in their reference.
Probably.
Maybe top 10 or 15 teams
But
only.
Anyway, we don't really need that.
Yeah,
in
we
this
don't
problem.
really need that here. Yeah.
But it is a common trick, and
Yeah.
But so strong zero solves I correctly. On 129th minute, we can move back to the scoreboard and see the most updated one.
So, are these submitted by judges, or just?
No. This is autogen.
No.
Yeah.
Automatically generated. Yeah.
Yeah.
So
I should push it to the ticker.
I think we got
Sorry.
2 or 3 teams at nine problems solved now, right? We got 2 teams.
2 teams getting 9
Strong
problems.
Zero managed to solve I on their first try. That is the convex hull problem.
Yeah.
And jumped back to first place. As I mentioned, they had a huge penalty advantage before. So now, H and J are the problem still to be tackled by Strong Zero. And we still have only one team that solved problem H.
Yeah, H is not that easy. We solved that at the 4-hour mark, so that one isn't easy.
Yeah, that's when they are doing
So this is possible if the origin is on the convex hull of the points or outside. Otherwise, it is impossible, and we'll need to do a more complicated solution. The first observation is that we can always move the line closer to the origin until it touches one of the points. So now we know that the optimal solution, the optimal line we choose, always passes through a point on the convex hull. The second observation is that we can always rotate a line in one of the directions until it touches another point, and it would also improve our solution. And this observation is not that obvious, but we can show it with some simple math. So we let the distance from the point to the origin be d, and theta 1 and theta 2 are the 2 angles of the 2 edges on the convex hull. Then we can choose the line through point A to have an angle like anywhere between theta 1 and theta 2. And every point will be on the same side of this line. So our goal is to minimize the distance, which is d times sine theta. And since these 2 angles will be between 0 and pi, the sine function is a concave function, which means that if we want the minimum value, it must be at one of the endpoints. This means the optimal choice for theta is one of theta 1 and theta 2. So that means our optimal line would always be one of the edges of the convex hull. So the solution is pretty simple actually. We just need to build the convex hull and check the distance from the origin to every edge. And let d be the minimal distance. And we can compute the answer by subtracting the area of a sector by the area of this triangle. And both of the areas can be computed by some math. And the time complexity is n log n from building the convex hull. Thank you for listening to my solution. Hello, everyone. Hello, my name is Ke-Wei Huang, and I'm going to talk about problem K, kindergarten homework. In this problem, we are given a grid of digits and operators. We can find expressions in the grid by combining several characters in a consecutive line. And we are given several queries. For each query, we need to answer how many expressions in the grid evaluate to that number. Here's a simple example. We can see that there's a expression 1 plus 2, which evaluates to 3, which is one of the queries. Or we can see that there is an expression 7 plus 16 times 45, which is 727. So we can count how many different expressions might be in a grid. And each expression can be formed by choosing a starting location, choosing a direction, and then its length. And there are n times m starting locations. And the maximum length in every direction is always between the maximum of n and m divided by 2 and maximum of n and m. This means that for each starting location, the number of expressions starting from it is always big theta max n and m. So the number of expressions is seen on the screen right now. And the total length of the expressions is like this. And for each expression, we can compute its value in linear time. This is the most simple solution. However, the runtime is equal to the total length of expressions. And when n is 30 and m is 1,000, the total length of expressions is about 10 to the power of 10, which makes this solution too slow. And one way to optimize the solution is to try to not compute the entire expression every time. So we can try to find a way such that we can add a digit or operator to the end of an expression and compute its value easily. And we can maintain 3 integers, cur, sum, and prod. Cur means the current integer at the end of our expression. And prod means the product of all the integers that will be multiplied to cur before our number. And sum is the sum of the rest of the expression. And here is an example. We can see that the value of the expression equals sum plus product times cur. And initially, we set cur to the empty number 0 and prod to the empty product 1 and sum to empty sum 0. And to add a digit to the batch, we simply add it to the number term. And to add a multiplication sign, we can update product to include the current number and reset the current number. And to add a plus sign, we update the sign to sum to include the current product. And then we reset product and the current number. And all of these operations can be done in O1 time. And we need to check if an expression is valid. If the last character is an operator, then the expression is obviously not valid. If the first character is an operator, or if there are two consecutive operators in the expression, then we know that after pushing any amount of characters to the end, it will still be an invalid expression. So this check will also take O1 time. And here are some implementation details. The first one is that expressions of length 1 should be counted once, not 8 times, according to the problem statement. The second one is to answer queries efficiently, because the query numbers are small, only to 1,000,000, we can store the answer to every possible query in an array of size 1,000,000. And the final detail is that the expressions can get really big, because we can have a very huge chain of multiplications. If we use big integers, for example, write it in Python, we might get time limit exceeded, because then the query is no longer O1 time. But to solve this problem, we can notice that if we add a character to an expression, it always becomes bigger. So once we encounter a value larger than 1,000,000, we can immediately exit the loop. And this is the final time complexity of our solution, since our solution takes O1 time for each expression and query. And the number of expressions is about 30 million. And this is the maximum number, which is obtained when n is 30 and m is 1,000. Okay, thank you for listening to my solution.
Yeah, so I mean,
Oh,
yeah, so we're now back and we
can see now
Yeah.
fruit advantage is solving n. Can we switch to the screencast?
switch to their screencast.
Yeah. Yeah, oh, they get a wrong answer. Let's see. I think they might probably miss some current case.
C?
Oh. N.
No, N.
They're
I think
solving
they're
N.
trying N.
Yeah, they're
right,
trying
yeah.
N.
They're trying N. So their N, I think they missed a lot of test data.
That doesn't matter really.
Yeah. There are wrong answers and there are also wrong time errors. Yeah. Probably missed by just a bit, and that one resulted in a lot of wrong answers.
H and K.
Advantage. Yeah. So now we have two teams at 10 problems solved. Again, they are Strong Zero and STD-ABS with Strong Zero.
Oh, Strong Zero submitting J.
Oh no, they are
Can they get it
trying
correct?
the 11th problem. I think they should get it right.
Oh yeah, they get it right.
They got it. They got it.
They
so
got
it's
it. So
now
they have 11 solves.
11 solved. At
Oh,
at 1:49. So they got 2.5 hours. That is half of the contest time to work on the remaining three hardest problems, C, D, and G. And they also have a huge time, the penalty advantage over STD-ABS and all the other teams that have.
We can switch back to the scoreboard.
Yeah, so 11 problems and 724 penalty. They should have I think, should STD-ABS.
Yeah, they have a massive lead.
No, they still have 40 minutes of advantage over STD-ABS. And
yeah, given this condition, if Strong Zero does not submit like a crazy number of wrong attempts, I guess if STD-ABS want to surpass them, they need to solve one more problem. Then Strong Zero. Yeah.
So they have to win by problem solved, not the penalty.
Yeah.
So as for the other teams in 8 problem solved territory, the 3rd to 7th team, I think Strong Zero currently have they got over 100 minutes of penalty advantage over these teams, apart from the 3 more problem solved. All right, so I think STD-ABS should work on N.
I guess so. Let's switch
I
their
think
screen.
we can check their screen.
Yeah. Yeah, they're working on N, indeed.
Yeah.
They are writing some bi-connected component checker to make sure that their construction is correct. They are downloading the sample of N.
So looks like they have finished their coding.
Probably. Let's see what they're doing.
Yeah, because they're trying the samples now.
Yeah, they are inputting the string.
They haven't finished the input
No.
part.
I think this is the checker.
It's the checker and maybe special case. Is it? Do they have special case here?
Let's see what they are doing exactly. Yeah, they're writing checker. I think they have a solution ready, or they might not have a solution ready, but they work on the checker first so that they can do some quick check before submitting to save penalty, because they need to have low penalty to win against Strong Zero. So I think they want to do things neatly.
Yeah, they cannot afford even one more penalty of wrong answers.
But
so
in this
yeah,
scenario, probably sometimes people don't necessarily care about penalty if they know that they can only win against
they can
another
win,
team.
yeah, they
by
can win by
solves.
problem solve.
In those cases,
Yeah.
penalty doesn't quite matter.
But that really requires a lot of confidence, because
No. Sometimes you need to play some risky.
yeah. But in this case, they only have 3 hardest problems to tackle.
Yeah, but
should they solve correctly?
even if you knew that you are already in a situation where
You can win.
you can't
by-
win by tie,
yeah.
then you should go all in, even if you sacrifice a bunch of penalties.
Yeah.
That would
Yeah.
sometimes be
Yeah.
the strategy.
Yeah, because losing by 1 minute of penalty is the same as losing by like 1,000, even 10,000 minutes of penalty. It's the same. You lose to that team.
Yeah.
Yeah. So sometimes, yeah, just like Chris said, sometimes you have to risk it. So what was the result of their try? On their local, they did not submit, right?
Yeah, they haven't submitted yet,
They're still-
and they are counting if the number of bridges match the requested number. Let's see. Are they running? Let's see. They're running on some. Oh, they are checking what's wrong with their output, because it seems that their output isn't valid.
Looks like they couldn't even pass the sample. Yeah.
Let's see what they are doing. I think it's quite exciting to observe at this moment, because if they get this correct, they SCD ABS and Strong Zero are both having 10
11,
solves.
11.
11 solves.
They will be at 11.
Yeah, and there are 2 hours remaining, so it is almost it is almost sudden death. Like one team solve one problem, and I think it is almost over.
Yeah, because those 3 problems are really,
pretty hard.
Really hard.
Yeah. But not necessarily. Even if SCD ABS solves one, I think if Strong Zero can solve another problem in time.
Yeah, they
some
got a 40-minute.
Yeah, I think they can win by time.
Yeah,
Fruit Avengers make another submission on N, but unfortunately failed.
Yeah, they failed again. So that one also. They made some runtime errors. Now wrong answer. I think that's a improvement.
I think probably they just removed some assertion. That could be the case.
It could be. Yeah.
Venator got a wrong answer on K, and NTHU got a wrong answer on I.
Yeah.
Yeah.
So now I think the pace.
Yeah.
The
scoreboard has been stabilized.
The pace is now slower for all the teams, because all the easier problems are solved, and the teams are now working on
harder problems.
Mid to hard problems. Yeah. Oh, and we're now seeing a team wanna go to Japan at 104th position. They got wrong answer on problem B. All right, so far we have all the teams solve at least one problem, and only 3 teams at 1. All the other teams have at least 2. That's quite a.
讲我比较 embarrassed team.
Yeah, so I think they're now coding and thinking at the same time. Looks like they.
Yeah, I see ABS is. I think they want to solve it case by case. They start by solving the case where n is less or equal to 4, the small cases.
Yeah.
But if I remember correctly, there is a very corner cases on n equals to 6, such that you need to make a specific construction for that.
So that one.
Yeah,
wow,
we can move on to problem.
the problem start. The smallest possible number of n is 2, right?
What?
Is this
No,
the problem
this
we're
is not
looking
the
at?
problem.
No,
No. You opened the wrong
This
problem.
is our problem. Sorry. So it's the problem n, and yeah, problem n, right? So yeah, so the smallest possible n is 1 in this problem, and Chris just mentioned is the special case is n equals to 6.
Yeah, it might be a tricky case. We can pull this problem here.
We just put the problem statement here.
Yeah, let's read the problem together. So, there are a story here, but we can simplify it as you're given n, k, and b, and you need to construct a simple n connected graph such that the number of odd degreed vertex, which means that a vertex is connected with an odd number of edges. Yeah, it is incident to an odd number of edges, and it's locked in with a specific number given by the parameter k. And also, there is another parameter b, indicating that you need to have b bridges in this graph. And by bridge, it means that if you consider the biconnected component, it is the critical edge that you need to walk from one vertex to another vertex.
Yeah, one to another.
So this is a constructive problem, and there are some tricky cases to solve.
Yeah, so basically it is the problem gives you some input n, k, and b, and you have to construct a graph that is feasible to this input. So
yeah, I think this is not an easy problem, but Strong Zero just managed to solve it.
You try to
in a very short time.
Yeah, maybe they found a way to construct.
Maybe they find an elegant way to.
Yeah. Do we check the solutions? Maybe. To see
I think we can have
the
solution of some easier problems first.
Yeah, maybe.
Yeah. Which problems can we take a look?
Yeah, maybe. I think we can check.
Problem L.
I think
L is better.
L should be easier.
Yeah.
Yeah, L should be.
Let's play the video.
Yeah, I think we can
tutorial of L.
Yeah, we do L first.
Hello everyone, my name is Ting Feng. Today we are talking about the problem L, maximum color segment. So the problem is described as follows. Given a row of length n with color red and blue, and a budget of n operations. For each operation, you can choose a contiguous substring of length k, then flip of the color within it. And your goal is to maximize the number of color segments after at most n operations. So first of all, you should think about how to calculate the number of segments. So between each segment, there's a cut between it. So you need to calculate the number of the cut point. So under this situation, we can define the array D as follows. So for each DI, it is equal to 1 if Si and Si plus 1 are different, and 0 if they are the same. So you can see the following example. There's the string S has the 5 segments and the array D has 4 ones. So the number of segments should be 1 plus the number of 1 in D, which is also the summation of D. Yeah, so now our objective is to maximize the summation of D under most M operations. Yeah. So next we should analyze how an operation affect the array D. So again, we take the following examples here. And for example, k equals to 3. And we operate the substring here, RBR. So we should focus on the left boundary and right boundary first. So take the left boundary as example. So these are changed to B, but the element after the left boundary doesn't change. So this DI should change from 0 to 1, or if it is 1, then it should change to 0. Similarly, you can see the right boundary. It changes from R to B, but this B doesn't change. So this DI should change from 1 to 0. Furthermore, if you see of the element D between this one, then they shouldn't change, because for each DI, the element in front of it and behind it, they both flip. So after these operations, the DI remain the same. So in conclusion, we can see that after each operation, there are only 2 DI flips, and you can see exactly the position difference is 3, because the length of substring is k, is 3. So now we can give a following conclusion. So an operation at L only fits the 2 difference points, DL minus 1 and DL plus k minus 1. So the position difference is exactly k. So from this point, you can see that actually we can decompose the array D into the k chains, because each change is independent. Yeah. So for example, if the chain R is dr plus k, dr plus 2k, and so on, then each operation will affect only 2 adjacent element Ds. Yes, and you should notice that there's some corner case. For example, if the string you operate is at the beginning, then there's no DI in front of it. And similarly, if the substring is at the end of the string, then there's no one here. So there'll be 2 corner cases that it is possible that you can change only one element D. Yes. Next, so how do we calculate? We can use the dynamic programming, and we can define the dynamic programming status like as described here. So we define dpxc, which is as follows. So x is the number of operation you have been used, and c is the final state of the current points you are located. Yes, and the value is the maximum total DI you can achieve. Yeah. So from the previous dpxc to the next dp new x and new c, you should consider now if the sj and sj the dj and the dj plus 1 the relationship between it, and you can list the follow state transition formula like this, and the remains the implementation details. Yes, so we will leave as an exercise. Yeah, so the final result is the 1 plus the maximum possible of the array D, which is the maximum of DPIC. And because the transition is O1 and there are exactly n times m status, so the time complexity is O n times m, which is which can be passed in within the time constraint. And for the space complexity, if you use the rolling array, you only need to use OM space complexity here. Yeah, that's all. Thank you.
Hello, we're back. So after playing the video solution of L, you can talk about a bit about D, because there we can see some teams are trying to solve it.
Yeah, we got 4 teams in top 10 trying D, and they all got rejected.
Yeah, it's a seemingly easy problem, but there are some twists and turns. Like,
maybe we can play.
yeah, maybe we can.
We put the problem description.
Talk about problem a bit first.
Yeah, we put the problem description on our screen. So, yeah. Problem D.
From D.
Yeah. Okay, so.
Okay, so it is called divisor card game, and we will have n cards, and each card is distributed to one of the students, and if the number is 0, it means that the card is distributed to the teacher. And the game proceeds as follow. The teacher first randomly draw a card from his bag, and when they display it to the student, all the student needs to play another card as their action, and whoever plays the card that is a multiple of the card of the teacher, and it is smallest one. For example, if the teacher gives a card of 5, and there are 3 students, they are giving 10, 12, and 15, and we can see that 10 and 15 are multiple of 5, but 10 is the smaller one. So the student who play 10 in this round can get the card of 5 as the reward. And if all the students play optimally, how many cards can each student get? So this is a problem statement, and there's a trick, like there's a trap. Like some teams, including us, when we were testing the problems, thought that we can do it like straightforwardly, but if you do some sanity check, for example, you just run some brute force solution locally and do some checking between these 2 solutions, you realize that it is actually not that easy. But because it's seemingly so easy, so I believe that many teams may rush into it and probably get trapped. I hope they can figure out what's wrong with it. Yeah, it is quite easy to construct a fake solution, but if you do it in a more cautious manner and do more assertion and local check, you will realize that it's actually not the case.
All right, so so do you want to analyze the teams that have tried like Strong Zero got a lot of wrong answers on that attempt. And yeah.
Yeah, we can see. Did they? Oh no!
No.
I see.
Yeah. Because there's a multiplicative inverse. Maybe they got it wrong.
I think it's hard to analyze such a hard problem in such a short time.
Yeah, and only by looking at their inputs and outputs.
We can actually look into their code.
Yeah,
but
we can check.
I don't think
code.
that's quite readable, even if we read the code.
They did some fix, but
yeah. Maybe we can check some other teams from on the borderline of maybe brown, between silver and bronze and medalist too. Yeah. The threshold of the medalist.
Yeah.
We can
so
randomly
currently
pick some
the
teams.
cutoff at bronze medal line is still 4 problems.
Yeah. Let's randomly pick some team.
No. How many teams we got? We have
half of them.
Yeah. NTHU to do. So now we check.
Yeah, so now let's take a look at NTHU to do. They're currently ranked
61st.
Yeah, 61st, and
under.
let's see if they can manage to get a bronze medal. They are working on, they are working on I.
So that's a convex hull problem.
Yeah.
They already got 2 wrong answers on problem B.
Yeah,
they're not working on.
Yeah,
problem
I think moving on to another solvable problems is important.
Yeah, because if you're stuck on the same problem, you might get. It is possible that you never get it correct.
Yeah,
before the contest
you
ends.
might get perpetually stuck.
Yeah.
Perpetually stuck. So yeah, it's important to move on.
And sometimes switching to another problem and then come back later would probably give you a better
insight.
Yeah.
But we can also move back to see how Strong Zero and STDAB is doing. The clash between, because the championship of this contest almost guarantee a ticket to the APAC championship. So it is quite important to see who is the winner today. And here we have the top 2 teams that are the most likely ones to get the trophies back.
Yeah, and also the World Final slot. Yeah, because in today's contest we have 1 direct slot for the World Finals and probably around 10 to 12 slots for the APEC Championship next year. But the exact number of these slots would depend on also the other sites in the APEC region. So yeah, we cannot confirm how many slots we have this year, but last year it was 11 slots. So the first place teams today, the champions, would go to World Final directly, and the follow 10 to maybe 12 teams would go to the APEC Championship. But there's another condition that is first, well, it's not just another. There are a lot of conditions here. So first, if you're in your institution, you got a team winning the champion in another regional contest, you will automatically be out of the APEC Championship. Second, if your institution doesn't have another team that are the champions of any regional contest, then your ranking in all the regional contests would be resolved by a formula, and you will have a coefficient based on that formula. And you have to be in top 80 for next Apex Championship. Apart from the top 80, you have to be in top 3 in your institution. So currently we look at the scoreboard. We have scoreboard. We have 3 teams of National Taiwan University in 2nd, 3rd, and 4th places. So these 3 teams have the chance to go to Apex Championship based on their overall rankings. And then in the 5th place, Lion King, Grand Park, PC Komaki, and Fruit Advantages, and other National Taiwan University teams, they are currently not in the qualifying zones to the Apex Championship because they already have 3 or more NTU teams in front of them. Yeah, maybe we can continue to which team is this?
Yeah, we have been displayed this one. We can move on to the screencast. This is the screen from Strong Zero. They are working on C, and currently we can see that they are writing binary search and some check. I guess it could be the correct solution.
I think the judges
the structure is correct.
Yeah, judges expected this solution.
Yeah, to do a binary search first and do some greedy internally. Yeah, they would probably solve it. We can also take a look at STDAVS, the runner-up.
So it's looking like Strong Zero might got their 12 problem in a short time.
SCDAVS is now working on N. They do some careful casework. Yeah, they separate a case where you need to do in N minus B plus 1 equals 2. It's probably one of the cases you need to take care of.
Is that the one we talk about?
It is not the one. There are a lot
earlier?
of cases to take care in this problem.
Yeah, okay. Yeah.
Yeah, we can also see some other teams. For example, PC Komachi. Let's see, Notebook. Notebook has 9 solves currently.
Yeah. They're trading by 2 problems, H and N.
Yeah, let's see which one they are working on.
I will guess H.
I would guess H.
2. Right.
Yeah.
Yeah. Is it what they're working on now?
But H
is that
it?
H?
Let me see. No, it's D. They are working on D.
Wow.
Yeah.
Wow. So
very ambitious.
Maybe they want their first to solve, or probably they just it's their strength.
As I mentioned earlier, this is a problem that have some pitfalls there. I'm not sure if they will get into those pitfalls or they will survive from that. But I think it's hard to judge what they are trying to implement currently because they're still writing some
I think it's the
modular integer.
Yeah.
Yeah, they're still copying some templates, so it's hard to judge what they are going to do.
Yeah, because yeah.
Oh, Strong Zero submitted C.
Wow.
Oh, but they get a wrong answer.
I think that's a wrong answer. Yeah. The C is a wrong answer.
Unfortunately.
Yeah. For the problem D, you, in the end, before you output the answer, you have to do the multiplicative inverse. So that was what the team SCABs was working on.
No, this one is Notebook.
No? Oh yeah, Notebook. Sorry, it's what the team Notebook was working on.
Okay, let's see.
Yeah, so
other teams.
Basically, they are just trying to type the reference in, and then I think they will proceed to the main part of the algorithm later. Alright, so No one tried problem G.
It's pretty hard.
Yeah, it's pretty hard. Okay, so now do we have,
yeah, I'm checking if which team could be exciting to take a look at.
Alright, so currently the silver medal cutoff is at 6 problems. And gold medal cutoff is currently at 7. We predicted 11, right? I think we predicted 11
what?
earlier for the gold medal cutoff.
No, I think 11 is too much.
Yeah, 11 should be.
I think 9 solves.
Yeah.
9 solves could be enough
but
to get it.
according to the 90 minutes heuristic, it was 11. But it could be.
I personally
it could be broken. It could
I
be
personally
broken
don't believe that.
Well,
I personally don't believe
it was precise for the previous editions, and there were no exceptions. But it could be broken this year.
Yeah.
It looks like there's a very, very high possibility it would be broken. Yeah. So we're still at 11 and 10 for top 2 teams, and there are now more teams solving 9 problems. Food advantage just passed problem N and move up to 6th place after 4 tries.
Okay, let's move on to another team. It's also another team from Taichung, the hosting city.
Thai Python?
No, it's it's Thai Python.
Yeah.
From Zhongxing University. They're currently working on problem B. They are using some monotone stack optimization, which is the trick I actually use when I'm testing problem. It doesn't require this complicated method, but I think implementing in this way is more straightforward in terms of thinking.
Yeah. Well, they changed a lot in their last submission. But looks like their submission is still doing some tests. Probably trying luck.
They are submitting. Sure. Let's see what they will get here.
A new submission?
From CyPython, yeah. As you can see on the screen.
Yeah, so is there a 5th
They are making a submission. Let's see. Yeah, it's their 5th attempt.
Yeah.
Let's see if they can get it correct.
Still wrong answer.
Oh, unfortunately. We hope that they can figure it out.
They passed a little bit more test data than the previous one. Still, there are some wrong answers.
Yeah. Let's check another team. Strawberry from Fengjia University. Yeah, this is also university from Taichung, the hosting city, and they're currently working on, let's see what's this. Oh, this is problem K. K is expected to be not that hard, so I think they'll probably manage to solve it.
Problem K.
Yeah. And they also start by iterating over the starting position or something like that. So yeah, hope they can
did they find the speed up that is required?
Yes, I think so. They have. I'm not
they
sure. I'm not
define
sure.
it?
They haven't reached into that stage yet. They are still
Yeah,
building up the framework.
because the naive solution looks quite easy, but as I say, it's
I don't
not,
think this
not
is.
it is naive solution.
I'm not sure. Let's wait and see.
Yeah, maybe because looks like they have not entered into the stage.
When they
So
they
far.
just started.
Yeah, they just
started to
yeah.
write.
So it's hard to tell if
several
they found
lines. Yeah,
if
yeah.
they found it.
Yeah, give them some time.
Yeah, let's give them some time. We checked on maybe IBIS, NSYSU IBIS.
That's why I asked you IBIS. Let's take a look. Let's see. Oh, they're working on I,
The convex hull.
the convex hull one. Oh, they have prepared polygon and monotone chain CMP, so I think they might get it correct.
But again, it's the edge case of the line.
The collinear case.
Test data. Yeah, let test data. Collinear test data.
I think it's, if you realize it, it's easy to handle, but
Yeah, but
it's not.
but it's not
No,
that
you,
easy
fruit
to.
advantage solved a
Yeah.
couple minutes
Yeah.
ago.
Yeah,
So they join the 9 problem solvers.
yeah, but they did some big modifications compared to their last
Their previous
Roland's,
submission?
yeah, to their Roland's attempt.
Let's see what they've written.
They added something.
Yeah.
Yeah,
They add some assertion to make sure that the answer is correct, and also add some condition such that
Yeah.
the condition is properly written.
yeah,
Yeah, they wrote some checking codes, making it easier to debug
Yeah.
and telling if it is a wrong construction or an invalid output from the
Yeah.
verdict. Because there's a common trick where you can do assertion, like you
Yeah.
assert a condition, and you can, depending on the the outcome verdict, you can know if what's going on in your code.
yeah,
Yeah, that's sometimes you need to do this penalty sacrifice to
Yeah.
know what's happening in the
yeah.
real
Because
test case.
Because it's always better to have one more correct solved problem than rather than you don't pass it but you don't try it. So
Oh, let's see. I've received a judge message.
I think we received some message from the
Just-
judges saying STAB.
Let's see what exactly happens.
Yeah, what was it? STABs?
Yeah, SCABS, let's check their code. I think they made a sad mistake in problem N.
Yeah.
But let's
problem
see what
N.
happened. So in their code, they accidentally output nkb again before outputting things. I believe this is the code that when they debug, they print it out
Yeah.
and to keep track of what the values nkb are. But in fact, they're
That's
no.
this-
No.
no.
no,
Yeah.
no.
Okay.
So yeah,
Yeah, but they operated something they should have never
Scoreboard.
operated.
yeah. They when they input nkb and they output nkb again before outputting their actual construction of the graph.
Yeah.
It's pity. We hope they can find them in time.
But also, I think it's hard to tell if
It's
they're-
hard to find this one because when you're debugging,
Yeah.
you don't really look into it. You just thought that it is your input
Yeah.
data, not the output from your own code.
And I think it's a little bit hard to tell from the data if there are answers.
I think they'll
out there.
eventually find it, but it is
Yeah.
yeah.
But well, looks like their other outputs are correct.
Yeah, looks like.
It looks like. So maybe
Yeah, maybe they
on-
just maybe I
may-
guess if they remove that line, they will get it correct.
Yeah, probably.
I think so.
It does look like, at least in the first few test cases, it looks like if they take that down off, they could pass the test data. Wow. So yeah, so you really have to be very cautious of what is in your program.
PC
And they
Code
try-
also come up with a construction.
But this one look far from the
Not quite far actually. Because this is a construction problem, so
Yeah.
if you only check on the diff output,
Yeah.
it is not accurate.
yeah, it's not that accurate because
Because you might come up with another valid construction,
Yeah.
which is different from the
And
solution, the intended solution, but it's also
but
a correct
fe-
one.
Yeah, correct one or feasible one. So yeah.
Let's see if there's anything in the chat room.
They actually tried it. Yeah, it was the second time. I think that maybe had just a miss on something because they passed almost all the test data, but got the wrong one.
Which one?
The PC Komaki on problem
Yeah,
N.
I think they fetched the rough idea, but there are some. Yeah, just
Yeah,
as
they
I
got only
mentioned, there are
only
there
one
are some-
test data wrong answer.
No, they have some skipped, so not necessarily only
Yeah.
one.
But I think it's the same set. Maybe very close.
Probably.
Probably, yeah. Probably very close to it.
Okay, so the bronze medal line has officially moved to 4 problems. You need to get at least 4 problems to get
Yeah, and with some
a
speed.
bronze
with some
medal.
speed.
Yeah.
And it is
Oh,
now
and
close
also
to 5.
and also the silver
Yeah.
medal have been moved to 6. So if you want to
Yeah.
get a silver medal, you need to have at least
And
6,
also
6
the
solves.
gold medal is now 8. It's not 7 anymore.
Yeah.
It's now 8 with some speed. It could get to 9.
I think it would be
But-
9
but
eventually. Like
it-
we still have 2
Yeah.
hours to go.
Looks like it would be 9 because we got
we
around
already
one-
have 7 teams
yeah.
having 9 solves
Yeah, we have passed
and 5 teams having 8
Yeah,
solves.
we passed 2/3 of the contest time. So, well, 100 minutes for these teams to solve 1 or 2 more. I think should be 9. It could be hard for all these teams to solve 2 more.
Yeah, let's see if
And
any team can solve
Strong
C,
Leader
D,
got
or
another
G.
wrong answer on problem C.
Oh, they get another wrong answer.
Yeah.
Let's see. Let's see what's happening there.
Only one test data
Oh,
incorrect.
did they? Oh,
I think that's a special.
I think no. Oh, it's a bit pity. Maybe we can move on to their
yeah,
screen.
yeah.
They almost get it correct, but
It's
there are
it-
some corner case and
yeah. I think that's a special case.
let me see.
Specially designed case.
No, I not that's not necessarily specially designed case, but
Yeah,
when they
but-
need
but-
to
but-
trim in,
yeah.
they forget to reset the infinity.
Ah, yeah. That should be the case.
Let's see if they can find the bug. I think they are very close because they missed some early test case. Yeah, they missed only 1 test case, I guess. And they have 2 submissions. And if we can like take the union of those accepted test case, they already passed this problem.
Yeah,
Like
yeah.
in the previous run, they get wrong answer only on test case 6, but on the following round they get it incorrectly in the 6th test case.
Yeah,
so
but
yeah.
but they did add some lines to their codes.
Yeah, let's see if they can find.
They did add something, and that one. Yeah.
But it looks like they have moved on problem D.
Is that a special case?
Maybe we can-
on that one. I think because they missed
Oh, yeah.
the.
What is
I think they missed the. It is the first test data.
Yeah, they also miss
yeah.
the sample test data. I think if they
yeah, one of the sample.
yeah, if they debug on the sample
So-
test data, I think
so-
they can pass it.
Yeah, so they should have found that because it's the sample. They should have found that before submitting.
I don't know why, but they are moving on D.
Yeah.
Let's also see what STDAB is
And
currently doing.
STDABS got another runs around N.
Did they remove that line?
Let me check. It looks like they removed it. They commented out the line, but I think they tried only commented out that line, passed some of the test data, but still got runs around others.
Oh,
So it's not just that
so it's
line's
not
problem.
yeah. Okay, I see.
They got some other problems too.
Let's see if they can. But it's cool because they have already written some local assertion.
Yeah.
But anyway, they also move on. Let's see which one is this. Oh, they move on C as well.
Yeah.
So strong zero moving from C to D, and STB ABS moving from N to
The other
C.
way. Yeah.
No, they're moving from N to C.
Yeah, N to C. Sorry.
Oh, Fruit Adventures gets to the third place by solving
H.
H.
Yeah. There are now also 10 problems.
They also have 10 problem solves.
Yeah.
We can also take a look at Fruit Advantages screen.
I think they are going to work on K now.
Oh, they haven't worked on K. Oh, wow.
They haven't. Not even a try.
K is a. Oh, K is actually.
Not even a try. Yeah.
I think K is overrated. Like.
Yeah, because
I mean, in
the
terms
K,
of difficulty.
I think the K
people thought
was the judges expected it was the fifth.
One of the easier.
Yeah, one of the easiest problems.
Easier, not.
Yeah, easier. Not the easiest, but it was the fifth easiest problems. So, yeah.
Let's see what Fruit Adventures is doing.
Maybe we can check on this. How?
Give me a second.
Yeah.
So what you see on the screen now is Fruit Advantages working on K.
Looks like they have the majority of the algorithms completed. Or is it?
Yeah, they're working on it, but they're running it a bit longer than I expected. But anyway, as long as it's correct, I think it's a good solution.
Yeah. But
yeah, maybe they can deliver a comeback if they solve this. They get 11 solves, and it become a sudden death between Fruit Advantages and Strong Zero. I think Fruit Advantages actually have some potential to get the championship better than CBS, probably because the problem they have in hand is easier. Like,
yeah,
I'm not sure if STD ABS can solve N, but I think Fruit Advantages solving K is just a matter of time.
Yeah, it should be, and maybe we can check their H. Maybe we can check H. Fruit Advantage.
Okay.
H.
Yeah, let's take a look.
Their codes. They did some very simple modification to pass it.
Yeah, let's shoot.
Nice.
Yeah, so let's see what they did.
They just moved one line.
They just moved the if condition of count addition to another line. Let me show it to everyone. Let's do this. See, as you can see on our live stream, the fruit advantage solves edge by moving that if condition, adding the counter of count to the end of the loop, and this makes them this brings them a correct solve on edge. Okay, let's continue to check on the scoreboard and see if there's anything exciting happening.
Yeah. Currently, Venator, I think they're trying problem C and D, but their estimations were like 10-20 minutes ago. So yeah, I think most of teams are kind of, yeah, we cannot say stuck, but probably taking some time to try to figure out what the problem want them to do and trying to find a solution for the top teams. And for the, maybe we can check on some midfield teams.
Yeah. Which team are you interested in?
Do we have
Oh, you can check on this list here.
yeah,
You can select some teams if you're interested. Let's see Ave Mujica from Providence
Avenue
University.
Yeah, Mujica. I think we can check on that. So they are currently at 4 problems solved.
They are browsing the scoreboard. Maybe we can move on to the screen test.
Because they just finished problem F. They just passed it.
They just passed problem F?
Yeah. They passed it I think one or 2 minutes ago.
Yeah, they solved it on the 204 minute
6 tries.
mark, and they are currently placed 64th.
Yeah.
74th, sorry.
Wow. Maybe we can show their codes.
What happened to their code?
They modified it.
They changed
long.
They change into long int so that their solution don't get overflow and they get they get it correct.
So that is also something you have to pay attention to the problem statements and also the limits. Yeah. Sometimes you will think, okay, a integer would solve the problem, but
submitting K?
Wow, did I get it?
Yeah, they get it.
Like
so
they got
now
it.
They're
they got
currently
it.
placed second.
Yeah, they're now second.
Yeah.
Although trading by a lot of
comeback.
penalties, but they now have a chance to win by.
What a comeback! They was, I think, 8th or 9th place in the early stage, but now they are currently ranked second.
They managed to get N, H, and K correct in the past half an hour.
Yeah, let's see what they
got
are going to work
they
next.
They
It's
jump
now
from
the
around
clash
yeah.
between. It's now the clash between strong zero, STD, ABS, and fruit advantages.
Yeah, I think they were around 10th place like 30 minutes ago.
Yeah.
And now they are second. Have a
They
chance.
got a lot of solves in the past few minutes. Oh, they instantly start working on C. Maybe they already get some rough idea on that.
Yeah, I think they do.
Let's see who will get the first team to have 12 solves.
Yeah.
Okay, let's see how strong zero is doing now.
Maybe they started to work on G.
G, really? Let's see.
I don't know, but they still have C and D in hand and still trying.
Maybe they printed out the code and let's see. Oh, they're working on D.
Yeah, on D?
Yeah.
Okay.
Yeah, they're working on D. I think they are not really debugging on C, or they have printed out the code.
Maybe printed it.
Yeah, they might have printed it.
Alright, so
let's also check some other teams. PC Komachi from National Taiwan University. Let's see what they are doing.
I think they're doing N.
Notebook and PC Komachi.
Well, probably on another problem now.
Notebook?
Because
let's see what Notebook's doing.
Yeah, Notebook still got H and N to go.
Notebook.
H and N should be easier ones.
I guess Notebook has roughly finished, and they are currently
just
running they're running their code. They try some sample input.
So they finish and now testing.
Sure. Yeah, it looks like they're testing.
But they're still scrolling their screen to look for some codes. Maybe they are just checking now. Can you tell from their trying inputs and outputs what they're trying now?
I think they are checking if all the output of no are correct. So they're running some sample NKB. And yes, it looks like they get it correct for the 744 case.
Yeah.
Okay, let's move on to PC Komachi.
Meanwhile, we got Raven Tulet from National Taiwan University. They had a correct problem K. So they are now also 9 problems and moved into 7th place. So now the gold medal line is almost 9 problems now.
Oh, PC Komachi is doing a local check. Like they write a brute force solution and they want to find if there's any difference between their brute force solution and their actual solution. They are now currently working on a Python script called ngen, indicating that they want to generate some test cases and see if what's wrong with it. And I think this is one of the expected thing to do when the judges are doing this, because there are too many cases and it's actually safer to exhaust the cases by computer, not manually.
Yeah. Let the computer do the work.
Yeah.
Yeah.
Let the computer exhaust the test cases. Oh, so we see CCU.
Zembu
Hikanai solving B and currently placed 64th.
46. And into the bronze medal territory.
They entered the bronze medal. And QWQGG solving J, and it looks like they'll get it correct.
Yeah.
And they advance to the 18th place.
To 18th. So now they also have 7. Alright, so currently we still have teams from National Taiwan University, 2nd, 3rd, and 4th.
Yeah.
And in fact, all the way down to 8th place, there are 7 teams in top 8, but not the first place.
What do you mean?
NTU, National Taiwan University, got 7 teams in top 8.
Oh yeah.
But not the first place.
Yeah.
Yeah.
Strong zero is strong.
Yeah, really strong. Really strong.
Maybe we can take a look back to the code versus mirror.
Yeah.
We haven't taken a look for a long time.
I think the team CRT they solve problem C really fast.
Yeah, they solved it on the 145th minute.
And their code is quite short.
Yeah,
actually.
a very neat solution. Let's see if PC Komachi can manage to find their bug with this method.
And STDABS is now trying C.
Well, STDA is now trying C.
Yeah,
Maybe let's take a look at
they
their
submitted
screen.
their first submission, and that one is the wrong answer.
But they almost get it correct.
Yeah, very close to correct. I think it's maybe an H case.
Yeah,
I think it's
maybe
an H case.
Yeah, let's
The
move
the
on
one
to
they didn't pass.
let's move on to STUS screen.
Yeah. Is it possible we see the input here?
Yeah, I think you can do it if you want.
Yeah, that's a special case. I think that one is a special case. Yeah, so they really are close, but there are some cases they...
PC Komachi get a segmentation fault when they are trying their solution on N.
Runtime? So,
Yeah, locally.
Oh, yeah. Lion King Green Plus now trying N.
STABS is now
And that one,
working on N.
That one's a wrong answer. Yeah.
They remove the B minus X minus 1 to B minus X. I guess it would be a minor fix if they get this correct.
Yeah, sounds like. Right, so now we officially have our Go-Mento line moved into 9 problems.
Yeah, and I think it will be 9 problems
It should
in the end, I guess.
maybe 10, but
No, I think it will be 9.
9 is
9 is more reasonable.
Yeah, it's more reasonable. Yeah, reasonable. Yeah, and maybe we get.
Yeah, what you're currently seeing is STD-ABS screencast.
Are we going to get 7 on silver middle line? Or just 6?
We can.
I think 7 is quite possible.
You mean silver? No, I think silver
silver.
medal line will be 6. I don't think
maybe
so many times
Yeah.
we'll get a silver. I think it will be stay at 6.
Yeah.
Because given that there are 20 silver medalists.
Yeah, 30. I think like 2 or 3 years ago we had one time there are a lot of teams got 10 problems.
Yeah.
All the way down to 29.
It's 2023.
30th was 9.
Yeah.
With a very, very fast speed. But the cutoff, you can only say 9, not the 10. So yeah, I think 6 is possible. And for the bronze, I think maybe 5. Yeah. We got 53 teams, so in 5 now. And still 80 minutes to go.
Let's see. Oh, STABS is simultaneously running C and L.
L? No, N.
N.
CNN. Yeah.
Oh, CNN, yeah. They are working on CNN at the same time. I think they get a bit confused.
They were very close to C.
How about N?
And, well...
Let me see. Not quite.
Not quite, yeah. I think N not quite. N is the one that had a small modification. I think it was the removal of the NKB output.
Okay, maybe we can also check.
They still got something to
You can
do.
also check Aizu 3 from University of Aizu.
Yeah, it's a Japanese team.
Let's see.
There are now 8 problems.
Yeah, they currently have 8 solves, and they're now working on K.
One more to go into the gold medal territory.
Yeah, but even if they get it correct now, 784 plus 200, it's still insufficient to
Yeah, it's not
advance to gold
it's
medal.
not enough to go
Yeah,
into
they
the
need
gold.
two more problems.
They can move to 11th place, but not in the top 10.
For any team, because you can see that the gold medal cutoff is currently 9 problems, but for all the remaining teams, like the currently 11th place NTNU to be down, they have 607.
Yeah, they all have to solve 10 to go
They
into gold
need to have
medals.
they need to have two more solves.
Yeah, because each accepted solution from now on is at least 220 minutes
Penalty,
of penalty. Yeah, so
it will incur.
so no one had a chance to move into gold medal territory if
Unless they solve 2 problems.
Yeah, they need two to move in. Only one is not enough. So that shows you how important the speed is when you don't solve fast enough in the early stage of the competition.
We get a lot of wrong submission on problem B. People are so aggressive on taking attempts on problem B. We have 189
Submissions.
incorrect submissions on that.
Oh yeah, incorrect submissions. Almost 200.
Yeah, almost 200. I think if I refresh the
Yeah.
page, it might be 200
It is 2 per team averagely.
in average. Yeah.
Yeah, in average it's 2 per team.
Oh, Lion King Grandpa gives SPA solves N.
They just
Yeah,
managed
so
to
there are
solve
3
N.
teams having 11 solves now.
So we can expect 12 or 13. It could really be 13.
I don't think I don't think there will be 13 solves.
2 12s?
I don't know. I think there will only be 1 12s. I'm more pessimistic.
But one of them is very close on problem C.
I think both of them are close.
Oh, both maybe.
Yeah, let's also walk through again all these teams. Yeah, I think ISO 3 is going to work correctly on K because
But
they have the framework correctly. They have iterating over all starting points and iterating all possible directions. And I think that's the good way to start it.
But I think there are they maybe have they maybe need some more works to pass these problems. I think maybe we can play the video problem J now.
Oh yeah, we can show the video solution of problem J.
It is quite a long video, but we can do it now. J.
Hi, today I'm going to introduce how to solve problem J, sliding tiles. So in this problem, you're given an n by n grid, which contains tiles stacked at the bottom of some columns. And there are some vertical bars, which are placed at the bottom between each pair of adjacent columns. So there are n minus 1 columns. We define 2 operations. The first one is tilting right, which tilts all tiles slide to the right as far as possible. The second operation is tilt down, which makes all tiles slide downward as far as possible. So this is an example. So we have this grid, and there are some tiles as shown in orange, and there are some bars which extends upwards. And in this example, we first tilt right, which makes some tiles move right. Like for example, for this tile, it moves the 5th column. And for this tile, because it was blocked by this tile, so it moves to the 4th column instead. So this is the tilt right operation. And then we tilt down, which makes all tiles move downward. So the task is pretty simple. You're given the tiles and some bars, and you have to determine the number of tiles in each column after performing both operations. So how to solve this problem? Well, first of all, we can make some easy observations. The first one is that tilting downward doesn't affect the count, which I think is pretty obvious. So we only care about tilting right operations. Because in this problem, the size of the board is pretty large, which is like 10 to the fifth power or something like that. We cannot simulate the movement of the block naively. So instead, what we can do is to do the sweep line method. So in this method, we simulate block movement column by column. And what we can do is, like, for each row, we keep a counter of how many columns that row occupies. And whenever we encounter a tile for that row, we add 1 to that counter. And if we encounter a bar instead, we clear a counter because we know that these tiles would be blocked by this bar. So we clear the counter to set this to 0 and apply a range addition to the last columns we examined. So this is an example that illustrates this idea. Where in the first figure, we don't know which tiles it was be slid into. And so in the second figure, we add this column, which we see are 5 tiles. And then we encounter the bar. And because this bar blocks the movement of the first 3 rows, so we have to clear the counter for these 3 rows and set it to 0. And because the counter is 1, so we apply a range addition to the first column. And now we add a second column, which is another 5 tiles. So we add 1 to those 5 rows counter. And because there's no bar between the second column and the third column, so we don't perform range additions. And now we move on to the third row, third column. For the third column, there are 2 tiles, so we perform range addition to those 2 rows. So the counter for these 2 rows are 2, 2, 1, 2, 2, respectively. And now we add, and now we encounter a bar, which is a length of 4. So now we have to clear the counter for these 4 rows, and then we perform a range addition respectively. Like for example, this row's counter is 2, so we add 1 to both column 2 and column 3. And we keep on doing this, and then we can simulate the right movement of the blocks. Yeah, so we can simulate the right movement of the blocks. So this is the pseudocode for the algorithm we just proposed. So C is the counter for each column, and R is the answer we want to output. So the pseudocode is displayed here, which describes the idea I just described. So it is pretty obvious that the solution represented is too slow, which is like O(n) squared time. So we have to speed up the solution. So the solution is pretty standard, is that we use one operation to perform the range addition part for the segments of same values. Like for example, if you have 5 threes in C, then it is equivalent to add 5 to the range of C of length 3. So what we can do is to use a segment tree to maintain the segments of the same values. And this is fast enough from a multi analysis because as you can imagine that each operation you do here and here will only add a constant number of segments. So like we will only need to deal with like an O(n) number of segments. So the time complexity of this algorithm is O(n) log n. Like and some extras I'll talk about here. So this problem in fact has many alternative solutions, either from testers or from other judges. So the solution one I'm going to introduce is to sort the number of tiles in some selected rectangles. So there's a fact that you can notice is that if the bar length of the grid is 0, then in fact that tilting right will sort the number of tiles in each column. So this is known as the gravity sort. So of course you cannot split the board into too many rectangles, but there's a solution that you can split the grid into some number of rectangles, and then we just simply have to sort the number of tiles in some selected rectangles. So if you do this carefully, you can make the solution fast enough. So the second solution is based on the fact that recording the number of blank cells instead of the filled cells instead. And although many implementations of this problem is quite long, we have a surprisingly short solution that is around 70 bytes long from a tester. Yeah, which is pretty surprising, and it's also very clean. So thank you.
In the past 10 minutes, STAB has come back to the first place with a single character added. They mistype J as I, causing them a bug, and they spot it now. So they came back to the first place.
Well, not sure if they mistyped it or they really wanted to put I there.
I think it's more likely a mistake. Yeah, no one
a typo.
no one heuristically changed code like that.
Yeah,
so I believe this is an error.
I personally don't like to put I and J in the outer inner loop because, well, on the keyboard, I know a lot of people do IJK, but on the keyboard, I and J is adjacent to each other and they look similar. So personally, I don't like to put I and J.
But then what would you use? I think I and J is good.
Usually I would
some.
put XY or YX or maybe I and then X because they for X, Y, or YX they are far from each other on the keyboard.
Oh.
And if you put I and X looks very different and they are also far from each other on the keyboard. But I and J is adjacent and looks similar.
I see.
So if you typo it there, even if your teammate is looking at the codes when you are typing, they are possibly they don't recognize it. Yeah.
Yeah.
So maybe we can check. Well, for advantages,
There are
they
two
also
teams
pass C.
having 12 solves, so strong zero. The original leader falls back to the third place.
They are now demoted to third place, but they are now trying C. If they got it yes, they would move back to first place because they had a penalty advantage.
Yeah.
They are not trying C. So
Can you connect to the judge?
I think they got a yes.
Oh,
Yeah, they got a yes.
strong zero get us also get it.
On the third attempt on
In
problem
the past
C.
minute, strong zero also gets an incorrect answer in problem C.
Yeah,
so now the
they
third.
are now back to first place.
Yeah.
Yeah.
It's getting back to a sudden death again. Like there are two problems remaining, and these three teams all have 12 solves. So yeah, whoever solves one more problem, I think they are very likely the final championship.
Yeah, yeah.
I think G is almost unsolvable during the contest. So I think it's only a matter of D.
Yeah. So whoever solves D first, or if they solve it and the other teams don't solve it, they will win. G is unlikely to be solved in the contest.
Yeah, I agree.
Well, they should be solvable if the teams reach 12 earlier, but if they reach 12 by now, I think G is very, very hard to be solved in the contest.
Let's see.
But these, I think, is quite possible for some teams to one or two teams to solve the problem D.
For the advantage, give 3 tries, but
they
none
did
of
3.
them was correct. And we're
in
in the last 4 minutes before the scoreboard is frozen.
Oh, strong zero is submitting D now.
Strong zero submitting D.
They're submitting D now.
It's loading for quite a long time.
Could be yes.
Could be yes.
Could be yes.
Could be yes. Oh wow.
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 So that means they
Oh no,
they were.
It's a wrong.
That one's a time limit.
That
That's
was
a time limit. So what are the traps in problem D?
If they get time limit
they
only get time limit on
two test data.
one test data. Oh, two. Yeah.
Two. They got
time limit exceeded on 2 test data, and this one takes 6 milliseconds more than the time limit.
Wow. And how about the other one? I think the one is
the
a
one
little bit
far,
much longer.
Yeah.
Yeah.
But I think they get the idea correct.
Yeah. Idea is correct. Maybe
already,
just some little speed ups they will pass it.
Yeah, I think
probably
very possible.
So now we have 3 teams at 12, 1 at 11, and followed by 2 teams of 10. Well, is that a clarification?
Yeah, that's a clarification.
Yeah. Okay. So, well, so we know. I think the contest will be decided by problem D.
Yeah.
Yeah. It should
Or
be
if no one solves problem D, then this I think will be very likely the final scoreboard.
Yeah.
And maybe we can introduce about a little bit about what is freezing the scoreboard.
Oh yeah, we're not closing to the point that we will have the scoreboard frozen at 4 hours mark, and now we are only 2 minutes away. So here's what will happen. The scoreboard will freeze at the 4-hour mark for everyone, of course, except for the judges. And so from that point on to the end of contest and before the awarding ceremony, the scoreboard will be frozen for everyone. That means what you see on the scoreboard now will be maintained all the way to the awarding ceremony. And then at the ceremony, we will reveal all teams' solutions, all the attempts, one by one. But so here we have some strategies here. That is, if you have a solution that you are confident that you can get it accepted, maybe you can delay it by 1-2 minutes and wait until the scoreboard is frozen, then you submit it. So all the other teams won't know that you have got a problem solved. So do you have any experience, Chris?
What?
Do you have any experience to
Before that, I think
or
we can talk
stories?
about story later. And
Yeah.
at this moment,
We got some solutions?
no, I think we can talk about before the scoreboard is frozen. I think we can give you some final highlight because
Yeah.
after
Yeah,
scoreboard
sure.
is frozen, we will not be sending you any screencast, neither screencast nor scoreboard. So I think it is important to take some final reviews now.
Yeah. Okay.
According to the screencast I just viewed, STD ABS and Fruit Advantages are working on G, and Strong Zero is
Wow.
working on D.
Wow.
So they have different strategy, and we will see what will be the final result. And we can also take a look at Lion King Grandpa. They are currently the 4th placed. And let's do it before.
No, they did not agree to share their screens.
Okay, so this is the final states of these teams, so we can place it as a ticker. So the latecomer can know what's going on.
Yeah, the scoreboard is now frozen. It is frozen
okay,
now.
you can continue.
Yeah, so do you want to share your story? Is there, if any?
Yeah, so sometimes
yeah.
Let me focus on placing this first.
Yeah, so Chris is busy typing the well, we had some news to share in the tickers. Well, okay, I can share my story first. So when I was a sophomore, that competed in my first ever competition. That was within my university in my school. I was third place just before the scoreboard was frozen, and I solved 5 problems. That contest was actually not easy. So there's problems, but there's solvable problems for us. And then I managed to find a problem that no one has solved, but actually not really that hard. And I solved it just before the scoreboard was frozen. But I didn't submit it because I am very confident that it will pass. It will be accepted. So I hold it until the scoreboard was frozen, and then I submitted, and of course I got a accepted. So with that solution, I managed to flip the scoreboard, and I am in the first place with 6 problems. But only I know that. No one else knows it.
Frozen, so we need to turn off the scoreboard and the queue.
Yeah.
We will only left the ticker.
We can
we'll
leave
leave the ticker
scoreboard.
here. No, I think the scoreboard will erroneously fetch the information.
It will? Okay. Yeah.
Yeah,
Okay.
I think I need to remove all the information about rankings.
Yeah. I think it.
We will take a short break now, and later on we will share you an interesting interview with us and some 2 researchers from France later. Yeah, see you later. 5 minutes later, we will be back. Well, after the break, we have invited two excellent researchers here, and we want to take an interview with them. And for Chuck, he's now preparing the closing ceremony. We will see him later. So, could you please briefly introduce yourself and your daily work and research interests and several things? Yeah, maybe you can go first.
Okay. Ni hao, thank you for having us. So I'm Florent Foucault, and so I'm an associate professor in the University of Clermont-Ferrand in France, in the middle of France. And so I teach and I work in computer science, especially in algorithms. And so my specialty is mostly graph algorithms and graph theory.
Yeah. Okay.
Thank you very much for the kind invitation to present ourselves here. So my name is Ralf Klasing. I'm a senior researcher with the CNRS in France. So the CNRS is the National Center for Scientific Research. So this is the branch for computer science. So I'm doing computer science, specifically algorithms. So I'm working on approximation algorithms, online algorithms, graph algorithms, I mean, different kinds of algorithms. And and because I'm a pure researcher, my daily work consists of doing research. We will maybe see a little later on exactly, and meeting with my PhD students, etc. I'm also doing some teaching, but I mean my main goal is to do research.
I see. Okay, so before rushing into some deep question, maybe we can have a interactive conversation with the audience on YouTube, and so now I will pose you some quick ice-breaking question, and you just talk about your habits, about your daily life. Okay, so are you an early bird or a night owl generally?
Well, I would say it depends on the days. I mean, sometimes you have a deadline, so you're forced to be a night owl. But I think the older I get, the more early I tend to wake up. So I guess more an early bird, right?
I see.
But when I was a student, I guess I was more of a night owl.
Yeah, most students are night owls.
Yes.
How about you?
Yeah, I think for me it's the same. I used to, well, I'm somebody who gets up slowly in the morning. And I used to be very good at working late at night, but unfortunately, the older you get tired in the evening. So
I can also feel the tendency.
But I still think I'm more like a night owl than. I mean, in the morning I have to take my time.
Oh, I see. Okay.
And the best ideas I tend to get in the evening as well.
Okay. Then do you identify yourself as an introvert or extrovert?
I think this is.
Something in the middle?
I was quite introverted as a kid and as a young, but again, I mean, of course, and then when you start teaching and all this, so of course you have to learn how to speak. And I think now I'm more in the middle. Maybe it's a balanced.
Yeah, I see. How about
between the two.
I think I can characterize myself as being in the middle as well, and I think it's well, when you're young, like Florent said, you tend to be, you work on, I mean, also when you're working, it's a lot, you work for yourself, you try to, but then at some point, I mean, you mentioned teaching, when you go to conferences, you have to present your ideas to people, right? And that's where you have to be extrovert. I mean, you have to convince people that this is working. Yeah. So I think I'm also in the middle, maybe slightly further to the extrovert, but not really.
Oh, I see. Okay. Then I know there are two researching style, at least for my surrounding students and some professors. Some rely on some eureka aha moments, and some rely on some day-by-day, step-by-step deduction throughout, like a very steady step of taking reasoning. What's your research style when you're working on your algorithm research?
Well, I think the two are not incompatible. So I think in reality it's a mix of the two, right? It's true that sometimes you have aha moments. I mean, sometimes when you're taking a shower or you wake up in the morning, or one time I was just going to swim in the lake and then I thought, oh, that's the solution. But I think, at least for me, the aha moments can only come if I have worked enough on the problem and thought, as you said, step by step, and then the aha moment may come at some point. So I think it's a mix of the two.
Yeah.
I think I can confirm, at least for myself, what Florent just said. So I think for me, I'm also like you have to like when you do research together with other people, you start exploring the problem, you work more and more, you understand more and more, and I think the aha moments can only come after really working hard on a specific, and then all of a sudden you see the solution, something like this.
Yeah, I agree with that.
That's how I am.
I see. Okay, and I think both of you are working on TCS field, right? If I understand correctly, you're working on graph algorithms, and you're mostly working on approximation algorithms. And if you need to use one word to describe TCS, what would you pick?
One word. I
Yeah.
mean, TCS is already 3 words. So, I mean, one word is obviously theory.
Okay.
I think this is clear, right? I mean, it's the first word of TCS. I don't know.
I always
Like you can use some subjective term, like if you need to introduce
Ah.
TCS and to let people know how the atmosphere there is for such a research field.
Well, okay. I don't know. I think for me, describing it in one word, I don't know. But for example, for me, the word comes up: fundamental, feasibility, important, fundamental subject for computer science.
Yeah.
So that's what theoretical computer science do, right? I mean, explore what is possible and what is impossible.
Okay. Yeah.
So I think that's the main
Finding the
content of
feasibility.
that's the main content of theoretical computer science for me, and proving instead of doing experiments, it's proving.
Oh, I see.
Yeah.
Okay. And
that was not one word. I'm sorry.
That's okay. That's okay.
I think proof is a good
proof.
Yeah, proof is a good word.
Proof is
Yeah,
a very
proof
good.
is
Yeah,
important
proof is a
because,
good. Yes.
As opposed to experimental computer science or experimental science in
A
general.
rigor.
Yes.
In theoretical computer science, of
Yeah.
course, we want mathematical proof.
Yes.
In fact, we could have said mathematics also. Because
Yeah.
Yes.
Because it's
in some
also
sense,
in some sense
it evolves from mathematics.
Yeah,
Yes.
I agree.
Yes.
Okay, and do you have any hobbies outside of work? Because people are curious about if the researcher also have any hobbies like beside jobs, because many researchers enjoy their work too much, and they don't really have like daily hobbies. Do you have any daily hobbies?
I mean, daily, I don't know, but
Not necessarily daily. Or
I mean, I do.
Weekend.
I weekly I do play badminton, so I like playing
cool.
badminton.
Wow.
Otherwise, I love nature, so I love hiking.
Oh, cool.
And it kind of mixes up well with the work. So I also like working with people. So a lot of visitors come, especially foreign visitors, and then I usually bring them to a hike because my city is near some mountains, so we go hiking in the mountains, with my visitors, my colleagues from outside. So.
Okay.
Yeah. So I mean, I live in Bordeaux in France, and it's very flat, so there's no mountains. But I still I like sports. For example, I like jogging because we have a nearby forest. So, and I mean, when you go jogging, for example, or hiking, I also like hiking, bicycling. When you're jogging all by myself, I often jog all by. That's where often you have to abstract from sitting down on piece of, and that's where the aha moments often come.
Yeah. Yeah.
So that's when you're really distracted. So in any case, so running, hiking, cycling.
I see. Cool. And there are also some quick questions, but slightly advanced and depend on more context. But I think you'll be more interested in. So, if you want to see in your lifetime, what's the theorem you wish you can see in your lifetime? That you can see proven in your lifetime.
What we wish to be proven, what do we think we can see in our lifetime?
You can do you can describe both.
Okay.
Yeah, you wish and what you expect to see. Yeah, some critical theorem in.
I think I mean,
or math.
As a researcher, at least in my research, I mean, you try to solve many problems. Some problems we can solve, but there are many problems we try a lot of very hard to work on, and we are not able to solve them because they're just too difficult for us. Maybe some of them are just too difficult for the field in general at the moment. So of course, any of the problems I have tried and I didn't succeed, I would like to see the solution, right? So there are lots of problems like that. Yeah. For example, there's one problem which I worked on during my PhD thesis, 12 to 15 years ago, which is a problem called identifying codes on unit interval graphs. I mean, it's very technical, but
you can do technical. I believe our audience are also studying computer science, and I guess if they are audience of this ICPC contest, I think they could be potential.
Sure, but maybe I don't want to go into the details. But anyway, it's some kind of problem which is similar to the dominating set problem in graphs, which is called identifying codes. And we don't know for unit interval graphs, which are special graphs which come from unit intervals. They're the intersection graphs. We don't know if there is a polynomial time algorithm for this problem on these graphs. So I spent some time on it, and I couldn't solve it. So I would like to see the solution of that. Yeah.
Oh, so it hasn't been proved NP hard yet.
I don't know if it's NP hard or if it. I mean, the problem is NP hard on general graphs, but for unit interval graphs,
I see.
or proper interval graphs, it's the same actually. We don't know if it's polynomial or if it remains NP hard.
Okay.
And that's a question which I really like.
Yeah. So for me, it's similar. I think when you're a researcher, I mean, you try to solve problems, and then, I mean, some of them you're able to solve, and some of them they're left open, and those are also for me the most interesting open problems, right? Not P equal to NP, but for example, for many years, nowadays less, but for many years I worked on traveling salesman problems. So I guess this is known to the audience, so I don't have to explain. And I mean, I always found it very appealing, this traveling, because there's so many variants, so many people have looked at it. There's the general problem, there's the metric problem, there's the Euclidean version, there's this small variant, and it's also okay, and it gives, again, here, like, we are doing theoretical research approximation, so we are trying to prove certain bounds, approximation bounds, whereas, but on the other end, this is used in practice, and they want real solutions. If possible, the best solution. So for example, what I always found very appealing, there's this algorithm that has been, I think, designed in the maybe even 1980s, I don't remember exactly. So this 3/2 approximation of the metric traveling salesman, the Christofides algorithm. Yeah. And the moment I saw this in my class somewhere ages ago, I found this because it was so easy to describe, so easy to analyze. And even nowadays, there's a tiny improvement from 2 or 3 years ago stock, where they carved off maybe 10 to the minus something in the, and it's only randomized.
Oh, I see.
It's not deterministic. So I find this fascinating. So people were able to prove some non-approximability bounds, but they remain very weak. It's 1.000 something. And the only positive result in metric TSP is this 3/2. And it has been like this for decades. And many people have tried it, and they cannot get the breakthrough. And so I would not bet my hand on it whether I would see this in my lifetime. The P equal NP I will not see in my lifetime, that's for sure. But this one I'm not sure, because so many people have tried. And this problem is, it's such a fundamental problem. If there's a breakthrough there, then it will spur breakthroughs in many other surrounding areas. I think that's why I also love this problem.
Yeah, that's one of the classical problems that will be generally introduced in computer science lectures in Taiwan. The 2/3. The 1.5 approximation,
And is it known as Christofides, or because there's also a second name, which nowadays is more and more known? But when I've had it for the first time, it was only known as Christofides algorithm.
Yeah, we also learned it as Christofides. I think one of our assignments was to prove that, read the proof and understand it and explain how it works.
And I like this proof because
it's so elegant.
It's elegant. It's everything a nice proof needs to have.
I agree with that. Yeah. Okay, and let's move on to, so for the audience online, I guess some of them, if they are still staying here with this conversation, I guess they must be very interested in being a future TCS researcher, maybe after years, or joining any PhD program. Do you have any suggestion for them? Like, according to your own experience and some pitfalls you think if you knew it when you're in your 20s, it would be a lot better. Yeah, some suggestions or
Well, I don't know, but it's not easy to navigate through the system, right? Every country and every university has its own system of application and all of this. So if your goal is focusing on trying to find a research or PhD position, first of all, you have to be aware of all the possibilities, which requires some effort. But I mean, for example, there's this mailing list in which is used in theoretical computers called DMA-Net, discrete mathematics. Actually, it's a mailing list which is managed in Germany, I think, and a lot of advertisements are posted there, so you can actually see.
DMCA.
DMA-Net.
Oh,
DMA-Net.
Oh, DMA net.
Yeah, you
Okay.
can register and they post lots of things. Among others, they post PhD positions, for example. Okay, if you are interested in a particular area or particular topic, a very good way would be to email or contact a researcher, a professor, and you can do maybe an internship with him. It could be online, actually.
Oh.
And maybe they have the time. I mean, of course, you have to be prepared to not receive an answer. So this might happen because people are very busy or they already have lots of students. But if you are particularly interested in a particular field, you could try that. I know people who have done this kind of thing. So they did an internship like this online. Maybe they were reading some things. And then the professor got interested in the work. He saw that this is a good student, and maybe then they apply for getting the PhD grant. So in France, the system is, I mean, there are different ways of doing a PhD. Indeed, one very good way is to first do an internship in a place, so to test the student for the master's, let's say, or master thesis, for example, and then apply for the PhD. Of course, then this is a good way to test if the relationship between the student and the professor is good. Because of course, a PhD, it's a human interaction, right? So you need to have a good. I mean, the characters should match between the student and the researcher. I think it's important for both sides. So sometimes some researchers or professors have their own grants where they can hire any student they want, but this is actually not so often in France. Usually the student has to apply, and then there's a competition between different students, maybe with interviews and so on, and they look at the CV. But there are different ways to get these grants, so it's a bit complicated. So the best is to try to contact the professor you are interested in working with, or and maybe he has no grant, but he has a colleague who has a grant, so he can maybe
networking.
Do like that.
Yeah.
So in my university specifically, also we have a master program which is called the International Master in Computer Science. So it's a one-year program, and we specifically recruit students who already have completed at least 4 years of their studies. They should have a major in mathematics or computer science. And the focus of this program, so we also have scholarships. So we give quite a lot of, maybe 10 per year scholarships for a student to come, and he gets a monthly allowance to pay for his housing and so on and so on. And then he stays for a year, and it's specifically targeted to research, and in particular, theoretical computer science. So in my department, we have a lot of optimization also, linear optimization, this kind of things. So this is a very good way, because then the student will do several internships with different professors, and then he can kind of see which topics he doesn't like. And normally, if he succeeds, there is a good chance of getting a PhD grant. So I think this is a very good program also to get integrated in France, because of course, living in France, you have to get used to it if you are a foreigner, and you have to see if you like it, and so on and so on.
Oh, I see. What about your take?
Okay, so I think Florent already gave a lot of very good information, so it's difficult to add something to this because, okay, we are working in the same country, so both working in France, not the same university though, so things might be a little different, but many things are similar. So for example, in Bordeaux, we also have like this international master. It's integrated into something which we call, maybe they also have it in Clermont. It's called a research graduate school. So the idea is to attract mainly foreign students to come to Bordeaux, first do a master, and then continue into the PhD program. And this research graduate school also has some funding, because I think it's the same in all computer science labs in France. You need to have some funding. You cannot, because I know in other countries you can do your PhD as a self-funded student, but in France, in Bordeaux and Clermont, I'm sure it's not accepted. You have to have some funding from some public agency, some separate funding. Another thing that well, I can only support everything that Florent has said. I mean, the relation between the PhD student and the supervisor is very important. I mean, whether they understand each other well, whether they can discuss with each other on an everyday basis very well, because you have to discuss about research, right?
Yeah.
And also, for example, what I think is very important is if you want to go to a country, go there for as a tourist, or maybe get invited for like an online internship, get invited for a one-month visit. If you have some money, visit somebody to say, look, because then you already know whether, because you may not like the environment in the town, you may not like the environment at the lab, you may not like the country. When you come to France, nowadays, when you start a PhD, it's no longer expected to learn to know French when you arrive, but the minimum is that your English is at a level that you can at least discuss.
Oh yeah.
And also we are in the lucky situation. It may be similar in Clermont. Ferrand, we are in the lucky situation for a couple of years ago because the university wanted to attract international students, so they started this part of the administration at the lab at the university, where they help international non-French speaking students, but you have to be able to speak English, to, for example, cope with the local administration. They are the link between the student and the local administration to get the work permit, to get the permit to stay in France, etc., etc. So that is very helpful. Anything else? I can just add, okay, maybe I can just add a personal a comment to a personal experience to this. So I did indeed, because I know that many of the contestants, spectators may be from Taiwan. So one thing I want to say, there may be a specific program from your country to go to France or, for example, and study there for your PhD. I had one PhD student from Taiwan that I co-supervised. Actually, if you're interested in going abroad, but you don't want to lose completely the link with home, for example, this PhD student was co-supervised by myself and some professor from NCKU in Tainan, Professor Xie. I don't know whether you know. Yeah. So that was, I think that's a very good way of doing it. Then how strong the co-supervision is, that's all up to, well, you have to see. But I think this going abroad, well, okay, I think everything is possible. You can go abroad, you want to stay there, get an experience for your PhD there, and then go somewhere else in the world or come back to, say, Taiwan in this case. But if you also want to sort of get the opportunity of working with both ends, that's also a possibility. So we had this, I mean, and this was actually the strong form of collaboration. This candidate then got a PhD in Bordeaux and a PhD from NCKU in the same defense. He only had to write one thesis, etc., etc.
Co-supervision.
So that's okay, but that's the strong form of supervision. Yeah, but so everything is possible.
I see.
So that's from my personal experience. Okay, I think that's.
Yeah, there are these possibilities of having this dual degree, but of course this is much more complicated.
Yeah, it's very complicated to implement. So I'm not saying it might not be possible.
Especially, I'm not completely sure it's very useful in the end, because I mean, having one PhD from France, I guess.
And also,
probably
yeah. I mean, I'm not saying you. I'm just saying from the experience. I don't say it may help. It may something that you want. It may not be something that you want. One thing I wanted to add. One aspect I wanted to add is, I think it helps a lot if your supervisor of your master thesis, for example, knows, and you express the desire to him to do a PhD abroad. I think it's good to talk to your supervisor. Look, do you have any research colleague abroad? And then it's much easier if your supervisor then contacts this. For example, for this student from Taiwan, it was actually somebody that I met while I was at a research visit in Tainan, at NCKU. And then the student came from Taipei, and we discussed together, and then, but okay, it was not, this was a student that somebody in Taiwan knows. So for me, it was already clear, this is, I mean, it's not somebody, if somebody sends you an email and you say, I'm interested in doing a PhD with you, then you say, well, you have no information about this guy. It's completely different than if a colleague of yours from Taiwan, I'm always saying Taiwan, can be any other country, contacts you and says, look, I have a very good student and he wants to do, then I think chances are much better. And many of the grants, okay, maybe that's the last comment for this first round. One thing is, there's many fundings in France that are depending on the quality of the student. But I think, if I understand it well, most of the participants here will probably be above that threshold. If you want to get a grant, there's certain grants that depend that depend on really how strong the student is.
Oh.
So, but I think this will be.
I think
no
many
problem.
students are pretty interested
Yes.
in diving into the TCS research
Mhm.
field, but from my perspective, a lot of my peers are, including me, might not be confident enough to get into this field because we think that okay, oh, this might be hard, and like,
Yes.
yeah, I'm curious. What do you reckon as the key personality or key mindset to be an excellent researcher? Like how to, one word is how to adult or how to grow up as a researcher. Like when you're just a student, you write a very basic linear algebra homework and you work on some very basic algorithm, and some sorting algorithm, something like that. But how to like cross the key obstacles between those classical algorithms to the modern algorithm and maybe develop a new ideas by yourself. Like for me, I think I I feel like there should be some key mindset that bring you to conquer this, yeah, obstacle.
Well, I mean, first of all, I think speaking for theoretical computer science and algorithms, as we said, proofs are important, right? So
Yeah.
the homework you do in your algorithms classes, proving that this algorithm has this and this running time.
Mhm.
I mean, this is actually the kind of things we do in our research.
Mhm.
And then, okay, so what do you need? You have to like proving things, like so you
Yeah.
have to like and the tool, the basic tool we use is mathematics to prove that. So of course you may not. I mean, I never really like this abstract mathematics, but still we use the basic mathematics that we need to prove the theorems in theoretical computer science in algorithms. So it is, you have to like that to a certain level. This is the first thing. So, what kind of personality? I mean, it means being rigorous. You have to be able to write and understand a logical argument and a logical flow in the proof. This is important. Um, yeah, so I think generally to do research, I think being a rigorous person helps a lot, right? Um, this is one thing. When it comes to, you said to develop new ideas and so on. I mean, in research, sometimes it's not about necessarily developing new ideas. Of course, we
I think
do
it's
that, but it's also
more about
sometimes about.
mindset, not
I mean, it's also about combining
Oh yeah.
old ideas in a new way, right?
Oh yeah.
So I think it is important to actually read a lot and to know a lot about the background of your field. So the classic things which actually were done in the 50s, 60s, 70s.
Uh-huh.
I mean, even I don't know all of it because there was so much done, but still, the more you know about that, so the more you have studied, and it is somewhere in the back of your mind that you can take it back, you might find an idea which has been used many times before, but it will be useful for a new problem which has never been explored. So I think this is important. So as a PhD student, I think learning, but even before your PhD, right, it's important to know about the old things which have been done, which are classic, and to remember them, and then being able to use them in a new way. So yeah, I think it's important to like working and learning about these things by yourself.
Yeah,
Yeah.
I see.
I think many of the aspects have already been mentioned. I think as a researcher, the first thing is you have to be curious.
Oh.
I think if you lose your curiosity about things, then I don't know, because you want to be, I want to know the result. I want to know the truth. As a question, somebody opened, I want to know the truth. And then I think, for example, what is being done is, so we talked about proofs. I think what you're doing in a programming competition is very similar to what you do as a researcher. You start with some model, somebody describes something to you, then the practitioners, they will, I don't know, they will try to find some system that solves this, and we look more like, okay, what can we do in principle with this? So we try to abstract, because quite often there's too many parameters. We try to abstract. That's what you're doing in the competition, right? There's a description, you abstract it into some, okay, now quite often the modeling is with some graphs, with some weighted graphs, and then, well, sometimes you can use some established algorithms on these graphs or partially to solve your, but if not, then you have to find some solution. And in the end, we would like to prove it, but quite often, just to say if somebody's curious, is this for me here? Quite often, I mean, what people nowadays often do is they test out algorithms practically before, and are they actually good? And then they try to prove it, or they want, there's a whole subfield of computer science, algorithms research nowadays, which is called experimental algorithms, where actually even have a new algorithmic idea or even take an existing algorithm and nobody really knows how to prove it. They all think, oh, this seems to be a good algorithm, but we cannot prove it. And then people actually try to prove experimentally that if you take, or like there's benchmarks where they then try to optimize this for the benchmarks. There's implementation challenges where they actually have to test those benchmarks and somebody gets a prize in the end if he gets a better solution than everybody else's. So there's a lot of things possible. But I think, okay, coming back on this question, what needs a researcher? I think you have to be persistent. You have to be rigorous and you have to be somebody who is not giving up after the first success. So you're trying to prove it doesn't work. After 1 week working on it, it doesn't work. It's not good then saying, oh, look, this problem is too difficult for me, right? Quite often when you come back to it and look at it from a different way, add some new ideas, quite often what you did during that week is not useless. You will understand the problem much better, and you will still understand it better. And eventually, typically you succeed. So I think this is also, I mean, a good characteristic for a researcher, to be able to go there all the way and not to give up.
Yeah.
But I think you should also, I mean, we often succeed, but we often fail also.
Yeah, okay. You have to know the right moment when to get up. Okay.
Sometimes you have to give up. Exactly. You never know. Maybe 2 years later, you remember the problem, think, oh, maybe I could look at it again, and then because it's 2 years later, you find a new idea, and then you may actually be able to solve it. But sometimes you never solve it. So But this is also hard. I mean, some people may be very frustrated, so you have to be able to.
You have to
cope with it and not be frustrated by not solving it. I mean, anyway, there are so many problems that maybe some problems you can solve, but it also requires know, to be able to overcome this. That you can't solve everything.
Yes.
Yeah, like how to be faithful despite maybe you fail to, like, you have 10 trials consecutively and you want to prove them and maybe work in this direction, but all of them failed. How to be faithful to still telling yourself that, oh, maybe you will someday, someday you will eventually solve them.
I mean this is often the case. Well, first of all, okay, I think strategies that researchers develop to cope with this is you don't work on one problem.
Oh yeah.
But first, okay, if you work on a problem, you go somewhere, you publish, or you talk to a researcher who knows he's very good at looking at problems from a different point. Then you maybe discuss it maybe by collaborate. I think collaboration is very important. That's what we're doing here in Taiwan. We're collaborating with people at the university in Taiwan. So that often because it gives different perspectives, you advance better quite often. And then, I mean, what is always good, not to say, look, I mean, let's dump the problem in the bin, but you put it on the side and you work on 2 or 3 problems, so that on some problems, for sure, you will advance. And then maybe half a year later, you have you read a paper. Couldn't this be applicable to what I sort of put on the shelf half a year ago? And then all of a sudden, yes, and then it's also true. But you have to be able to do this. You shouldn't say, no, that's a complete miss-success. No, it's not a miss-success. This happens. I mean, this is when I have 2 kids, and it's cool. Everything is possible, right? So in mathematics, they give you a problem, they know the solution. The teacher will give us the solution at some point. And it was very interesting when for the first time they encountered, or when at the library we have these where students from the high school come, and then they give them some very simple puzzles, whatever, to play with, and they think that we have the solution. No, it's a research problem. It's the first time in their life that they experienced research, and they learn that, nobody knows the solution yet. It's for us to invent the solution. And that's and I think this is really, like, as you said, this is a step that you have to get over. And if you want to become a researcher, you have to be able to get over this step. That's for sure. Otherwise, then it's not for you.
Yeah, got it.
But I think that's an important idea to say collaboration and asking somebody maybe exactly. It's maybe two people have different perspectives on the same problem. Sometimes also you're not able to solve it completely. You solve it for a special case, and then maybe you still write a paper and you publish it, and then it becomes freely available, and then some other people who have a different, they will solve it instead of you, right? Because you basically gave them motivation for the problem, and they thought, oh, this is nice. So you actually helped solving the problem, even if you solved only a special case, and maybe it triggers some other people to actually solve it. I mean, this is what happens constantly in research, that we motivate each other, and you maybe make a tiny step, but this step will be enough for another person to actually make the next step, and so on and so on.
It's a rally.
Yeah, in some sense, yeah, you could say.
And that's why, maybe coming back on this, that's why also, for example, this collaboration, international, okay, there are also researchers who prefer to work by themselves. Most of them don't, but there are. I prefer to collaborate, to work with people, because then you have different perspective. Also with your PhD student, I mean, the PhD student brings a completely different perspective. That also, it's a kind of collaboration which helps both, I think, the supervisor and the student. And for collaboration, it's really like this. I mean, you have a different perspective. That's why I would also encourage PhDs potential to I think, sure, you can do your PhD in your country, and I think it's your personal choice. But even if you, well, either to go abroad, but even in your PhD, if you decide to do it in your country, I would take the opportunity to visit somebody in another lab for a month or so, to start working on a problem. Because in every lab, in every country, in every town, people have a different way of working, a different way of looking at things, and you will only learn from this how to approach, maybe this problem, I should also approach it from that point of view. And that only makes you bigger as a researcher.
I see.
I think on top of the cultural aspects, I think you also, personally, I think you also learn a lot if you move.
You mentioned the experimental algorithm.
Yes.
I know there are some researchers who dislike this this manner of treating algorithm problems. Like the four-color theorem was proven by
by machine.
By machine, by case working on a lot of hundreds of cases. Like, what's your take on like using computer or algorithm to write a mathematical proof or do verification? Like, what's your subjective attitude on that?
Yeah, so I mean, I think it's very valuable to have proofs also when they're machine assisted. But of course, I think many people, at least, it's still frustrating, right? I mean, you of course, I think we prefer a proof that we can understand, just by reading it. But I mean, sometimes you have proofs which are hundreds of pages, even without machine. And in some sense, it's a little bit the same thing, right? If you have a proof that's hundreds of pages, you are not going to read it. So the same as you're not going to read that code. So okay, maybe you can read a high-level description of it, and then in some sense, it's the same whether it's now written by a machine or if it's hundreds of pages written by humans. Yeah, but no, I don't think it's bad. Of course, I think, and nowadays, you can also certify that the machine proof is actually correct.
Yeah,
I mean, you have this
by software verification.
You have software verification software.
Yeah.
Yeah, but of course, the best is when you first have a machine proof, and then you can actually find a human proof. But still, for the four-color theorem that you mentioned, we still don't have that. So it is quite frustrating indeed.
Yeah, I think I have the same point of view, like Florent on this, on the experimental, on machine-assisted proofs. This on the experimental algorithm side, I think. Well, okay, sometimes. In theory, we can prove that, for example, we can prove that certain algorithm, we have all these concepts in algorithms theory, like approximation algorithm, p-TAS, fp-TAS, fpt, etc. And so the theory tries to express efficiency in a certain model of algorithms. And then we prove that, for example, typically an algorithm is supposed to be efficient when it's polynomial time.
Yeah.
But if it's like n to the 7, then no practical person will actually implement this algorithm because it's just too slow.
Oh yeah.
So from that point of view, I think it's important. I'm a theoretical computer scientist. I think it's important to have those proofs and because then you understand much better about the problem. But whether the person who actually implements and applies needs an algorithm for this problem, actually implements this algorithm, that's another story. Because then the practical people, they're more interested, I have a specific problem, I want to solve it as fast as possible, as well as possible. The person, like coming back to TSP, the person is not interested in a 1.5 approximation. He's interested in the best, as close as possible. And maybe this because in algorithms, we often have worst case analysis, right? So there may be one case where we cannot, there are examples for the TSP, metric TSP. So where there are cases where we cannot do better than 3/2. But this is worst case. And in the practical scenario, maybe the person is working on some instances where the worst case never appears. So in that case, maybe even the Christofides algorithm may have a much better performance, and maybe some other algorithm that's we refer to as heuristic may have a very, very good performance, but somehow people are not able to formally prove. Yeah, I mean, the person who's paying you the money to solve the problem will still be happy with the solution, right?
Oh, yeah, right.
Even though we cannot prove.
Yeah.
So I think it's not an either or. I think it's a nice complementation.
Yeah.
And for example, as I said, well, maybe I can mention. So I have this one starting PhD student. He's working on streaming algorithms. So that's where you don't know the whole input of the graph, but the input comes. It's a little bit like online, but a slightly different model where you're mainly concerned about the memory that you use. You want to use little memory for what you're doing. So you cannot fill the whole input into memory and then do your algorithm, but the input comes, you have to do something, and then you have to free memory it. And so, for example, I mean, at the moment, we have several candidate algorithms. We have some partial proofs or some, but before we really invest time to prove a certain algorithm, we will first test out 5 or 6 algorithms to see how they perform on benchmark instances that other people have looked at in other papers. Because even on experimental algorithms nowadays, you have conferences for this. So I think all the big nowadays algorithms conferences, they have the main track, and they typically also have an experimental algorithms track. And there the expectation is you will show algorithms that perform well when you experiment them, and maybe you can prove some partial results, but you cannot fully prove that this is a good algorithm. But in practice, it solves 9 out of the 10 benchmark instances on this and this. It improves it.
Oh yeah.
But we cannot prove why.
Yeah, but sometimes that's sufficient.
Yeah. And for these conferences, as I said, that's a perfectly acceptable thing. When I was a young researcher, because I'm senior now, when I was a young researcher, that didn't even exist. So experimental algorithms said exactly this thing, like, we don't really want it, we want to prove. But nowadays, it's a way of, like, if you cannot prove, instead of throwing the problem away, maybe you can still show that this algorithm, I cannot prove it only partially, but maybe this algorithm can still solve much better the problem that I want to solve, and that's enough in practice, maybe. So it's, for me, that's okay. I prefer to prove, of course, but if I cannot, then experimentally is okay as well.
Yeah, I see.
I'd like to mention also that, in fact, there are, in theoretical algorithms, there are many people who actually also implement the algorithm. So just to give you examples, there are conferences which are more in theory. So, for example, SOSAGE, which is the SOCG, which is the one of the main computational geometry conferences. Every year they have a challenge, programming challenge. They give a problem in computational geometry, and they give a few instances, and you want to solve these things in practice. So I think it's very close to what you're doing in ICPC. Well, except that maybe you have a couple of months to solve the problem, not 5 hours.
You don't have the time constraint.
And also IPEC. So IPEC is the main conference for the parameterized complexity community, which is a very theoretical field. But every year they also have this PACE challenge. It's called PACE, P-A-C-E, which is also a programming challenge. So, for example, to compute, I don't know, the tree width. I think this year it was a dominating set, solving the dominating set as fast as possible. So they give some instances, and people have to come up with practical algorithms. And these are very theoretical communities, so they're still concerned about the practice. I think, as Ralph was saying, it's more and more recognized now, even in theory, that
it used to be badly looked
both
upon,
theory and practice should actually work together hand in hand, I think.
Yeah, that's great. Yeah, good to know. Okay, and I think it's roughly at the end of the contest at the same time, so maybe we can conclude our interview. Thank you for coming today. Yeah,
Thank you very
for
much.
sharing
Thank you
so
very much for the
valuable
invitation.
I would like just to add, I mean, if any of the
Yes.
viewers have any questions, feel free to email us. You will find
Yes,
our
I mean,
profiles
the-
online, and
Yeah,
our
and
email address is there.
The organizers will also know our contact, so contact
Exactly.
them. They will contact us, and we will respond to you. Thank
Okay,
you very much.
yeah, thank you very much for
Okay.
your time. Thank
Shijie.
you.
Thank you.
Thank you.
Thanks. We can
Just
speak
a
later.
second.
We can
Yeah, we can
speak
speak later.
Okay. Okay.
So will you make the presentation again afterwards?
Yeah.
Oh, for the award. Great.
Okay. So, thanks for your time for the two excellent professors. We will share you their email if you want. You can leave a comment below. And the contest has just been finished, and we will soon be moving to the closing ceremony to see who get the championship. Thank you, everyone. Thank you all the audience online. Thank you. Bye bye.